Hello, everyone. My name is Vincent, and today I'm going to be going through the thinking skills paper of the actual 2021 selective school test. So in today's video, we'll be doing a detailed breakdown of all 40 questions, and we'll also be discussing the best ways and strategies to approach these questions. And hopefully you guys find this useful. Without further ado, we'll start by going through question 1 of this paper. Be right here. Okay, so question 1 is saying a piece of rectangular paper is folded in half and then in half again. The second fold is at right angles to the first. A corner is then cut off the folded paper. The paper is then completely unfolded. Which one of the following is not a possible appearance of the unfolded paper? And they let us know that the dotted lines represent the folds. Okay, so for these types of questions, let's just bring it back into focus. What we want to do is, first of all, identify what's happening. So we know that we fold a rectangular piece of paper in half and then in half again, and then we cut a single corner. So an important thing to notice is that only one of the corners is cut off, and then it's completely unfolded, and we see 4 potential answer options. And we want to find the one that's not possible for it to occur. So there's 2 ways of approaching this question. The first method is the more thorough one, and it actually involves folding the paper and drawing what the diagrams would look like. And what we want to see is if the dark shaded corners align. So what I mean by that is I'll take you through an example of one. So let's say, for example, we consider option A first. Okay, so what we're going to do is we're going to fold it along the vertical line in the middle as drawn there, and we're going to bring this side of the paper, the right hand side, over to the left hand side. So we're going to fold it like that, and we're going to draw a diagram of what we should look for, or what it will look like. So if we do go ahead and do that, what will occur is something like this. And over here, right? So that's what the paper would look like if we folded it from the right hand side to the left hand side. And then we'll just do it one more time, but this time we're gonna fold it along the horizontal line, okay? And so if we fold it from the bottom side to the top side, what it would look like after that is something like this. And this corner over here is what's being cut off. And you can see that the dark corners, the darkly shaded corners, they all align perfectly into this one little corner on the side, which is the one that we cut off. And therefore, option A, because the dark shaded corners all align, is a potential one of the scenarios where we cut off a corner, like shown here, and when we unfold it, it shows us what option A looks like. So we know that option A is actually, it is a possible appearance of the unfolded paper, and therefore it's not the answer that we're looking for now. Remember, we are looking for one of the following options that's not a possible appearance, okay? So with method 1, where you actually draw the diagrams, so let's call this method 1, and we draw the diagrams. This way, we will just need to repeat it for all the other answer options until we see one where the darkly shaded corners, they don't align perfectly. Now, it does take a bit of time to actually draw the diagrams for all 4 answer options. So what I'll tell you now is the second method, which would be more useful in the exam setting. And it's a bit of a shortcut method, okay? Now, with this shortcut method, what we need to do is we need to look for symmetry across the middle vertical fold. The middle vertical fold. Okay, so what I mean by this middle vertical fold over here, it's exactly the one I've drawn for you guys. It's these middle vertical folds. Okay. And over here for option B as well. Now, what we should expect is if only a single corner is cut off the folded paper, when you actually unfold everything, it should look symmetrical across this middle vertical line, right? So now let's quickly eyeball all the options and see which one is actually symmetrical across this middle vertical line. An easy way of thinking about this question is treat the middle vertical line as a mirror. Okay, it's a vertical mirror, and is the left-hand side symmetrical to the right-hand side? So you can see that in option A, it is symmetrical, and that means that it is a potential appearance of the unfolded paper. So we can actually cross out option A. You can see in option C, again, it is symmetrical across this vertical mirror, and so therefore that also cannot be our answer. And you can see in option D, again, it is symmetrical across that vertical mirror. The only answer option that does not have a symmetry across this vertical mirror is option B, and that is our answer. Okay. So in the exam setting, what you want to do, especially because thinking skills is a quite time-intense paper where you only have around a minute per question, is you want to look for these shortcut methods, okay? And in this case, it is looking for a symmetry across the middle vertical fold that will allow you to get to the answer as quickly as possible, okay? And let's now move on to question 2. Right, so in question 2, we now have what we call a style of problem solving question, where they give you different bits of information and you have to interpret it together to solve a particular question or problem. Okay, so let's have a look at it. It says that 4 students had a race to see who could get to the top of the hill and back first. And they give us a bunch of different conditions, right? So we know that no one arrived back after Bruce, only one person was faster than Ethan, and James finished after Ethan. Where did Stephen finish? Right, so there's a lot of information that's given here. The best way to approach these types of questions is to actually draw a diagram. So the method that I would recommend, or the approach, is by drawing a diagram where you can visually summarize all the information in one diagram, okay? So we'll basically have 4 students in a race. What I will have is the last position on this side and the first position here. And we know there are 4 participants, so I'm going to draw 4 lines to represent these 4 students. This is going to be first, this is second, this is third, and this is fourth. And once you've got your diagram ready, you start filling in the conditions as you read them. Okay, so the first one we're going to look at is no one arrived back after Bruce. So if no one arrives back after Bruce, that means Bruce must have been in the last position, since therefore no one else would be behind him, right? So what I'll do is I'll place a big B here for Bruce in the 4th position, since we know he's last. And what I'll do is also tick it off here, so I know I've actually already included the information from that condition. Now let's look at the second condition that's given. It says only one person was faster than Ethan. So if you think about it, if only one person is faster than you, you must have therefore come second. And that's what Ethan was. So we're going to write a big E for Ethan in this second position. And we're also going to tick that condition off because we've used it in our diagram. And that brings us to our third condition. It says that James finished after Ethan. Okay, so Ethan came second, right? And James finished after him. So James must have been 3rd or 4th, but we know that Bruce is already 4th. So that means James has to be in our 3rd position. So a big J for James, leaving us with Stephen as the 1st position. So Stephen now has to be 1st, and therefore our answer for question 2 is A. And you can see that by drawing a diagram and putting all the information into one diagram, it's a lot easier to analyze what's happening and get to your solution the fastest way. Okay, so now let's have a look at question 3. Now in question 3, this is actually a type of question called detecting reasoning errors. And before we actually dive into the specifics of the question itself, I just want to give you an overview of what these types of questions look like. And there's essentially 2 major parts to it, okay? Usually they will give you some sort of scenario or information, and that's always in the box that's provided. So that's over here. We say the given scenario. And based on the scenario, someone is going to make some sort of conclusion. In this case, it's Ms. Walker, right? So there will be a given conclusion. Sometimes there will be an argument as well, right? Okay, and this conclusion is based on the scenario that's given to you. And the last step is, so this is step 1 and that's step 2. The last step is we have to figure out where Ms. Walker has made some sort of assumption or reasoning error in her actual conclusion, okay? So we have to identify the reasoning error in the provided conclusion. Okay, so just to summarize that one more time, you're given a scenario, that's step 1. Someone makes some sort of conclusion or argument based on the scenario, and our job is now to identify what sort of assumption or reasoning error they have done when they made their conclusion. Okay. All right, so now let's have a look at the question itself. It says, Ms. Walker would like to investigate whether drinking milk with lunch makes any difference to her students' results in a times tables test. She decides to do an experiment. She splits her class into 2 groups according to their birthdays. For 1 whole month, students who were born between January and June are given milk with their lunch, and students who were born between July and December are given juice. After 1 month, she gives the whole class a times tables test. On average, the students who drank milk with lunch score 5 marks better than the students who drank juice. Okay, so just to summarize the scenario, we know that there's a teacher who wants to do an experiment on whether milk makes any difference to her students' marks. And after the experiment, we find out the students who drank milk, they scored 5 marks better than the students who just drank juice. Okay, and let's have a look at Ms. Walker's conclusion. Ms. Walker says, so it's true then. Drinking milk with lunch improves students' ability to remember the times tables. So what we want to do now is we just basically want to write out the conclusion in some sort of a flow chart, okay, just to make it a little bit easier to interpret. So what I might do is I would say having milk with lunch, that's going to lead to higher results or higher marks, okay? That is the conclusion that Ms. Walker has come to based on her experiment. What we now need to do is find the flaw in her reasoning or any assumption she's kind of made when coming to this conclusion, right? So I might just write here conclusion so you guys know that that is the conclusion, okay? So if you read the question now, it says, which one of the following sentences shows the mistake Ms. Walker has made? So I'm just underline or I'll circle mistake to highlight it for you guys. So when you actually approach the answer options, generally I like to take an elimination approach. You want to read through the options one by one and eliminate any ones that you think are irrelevant, okay? And what you are trying to look for is an answer option that breaks this logic. You need to look for an answer option that breaks this logic, Okay, so I'll just write a note here. Look for an answer that breaks this logic. So Ms. Walker's logic right now is that having milk with lunch leads to higher results. We need to look for an answer option that either breaks this logic by introducing something else, or we need to now eliminate options that are completely irrelevant as well. Okay, so let's look at option A. It says some of the students might drink a lot of milk or juice at home. Now, when you drink a lot of milk or juice at home, that's kind of irrelevant to what the given scenario is. In the given scenario, the students are given juice or milk to drink with their lunch, and then they're doing a test. So whether you drink a lot of milk or juice at home seems kind of irrelevant to the scenario. So in that case, I will cross out option A, and just for our learning purposes, let's write irrelevant next to that. Now let's look at option B. B says the students who drank milk might have been better at times tables before the experiment even started. Now that is a pretty good option because it suggests that the higher results that the students got, it's not to do with drinking milk, it's because they were smarter to begin with. Okay, so let's say students were smarter to begin with. And you can obviously see that this option B really breaks the logic in Ms. Walker's conclusion, because she thinks that it's the milk that's causing the higher results. But option B is saying, wait a second, no, these students were smarter to begin with. It had nothing to do with drinking milk. And that definitely breaks the logic in Ms. Walker's conclusion. So I could positively say that option B is going to be one of our strongest options. But just to be safe, we should just look at options C and D. And that's always a very important habit to have in these exams, is to read through all the options to make sure you've got the best answer. So right now, B seems like a very possible strong answer. But just to make sure, let's look through C and D. So C says the students who drank juice might do better in other kinds of activities. Again, that is very irrelevant to our scenario. Our scenario is talking about specifically their results in the times tables test. So whether drinking juice might allow them to do better in other kinds of activities is very irrelevant to our scenario. So again, I'm going to cross that out. And then option D says more of the students may have been born between January and June than July and December. Again, when the students were born is kind of irrelevant to the given scenario. We know that their birth dates were simply used to split them up into the two groups. So it's nothing to do with the actual number of students in each group. So again, D is what I would call irrelevant to the scenario. And that definitely certifies that option B is the best answer option here, and that is the correct answer in this case. Okay, so now let's move on to question 4. Question 4 is again, another type of problem-solving question. In this case, it's a type of problem-solving question I call relevant information. So what that means is they give you a lot of information either as text or in tables or graphs, and you need to identify the relevant information you need from that in order to answer the question. So they will try and overload you with a lot of information, and your job is to find the ones that you need to answer the question, okay? So let's have a look at question 4. In a competition, 11 students were allowed to 2 attempts at jumping as far as possible. The longer distance in the 2 attempts would be counted as their results. The attempts for the 11 students are shown in the table. And the question is, which student came 5th in the competition? Right, so we know from the question stem that it's the longest attempt that counts. So what I would do right now is for each student, I'm just going to circle their longer attempt because that's the information that we need. We don't really care about the shorter attempt. Yeah. So for student 1, you can see that attempt 2 was 5 meters, attempt 1 was 4.9. So it is the 5 meter attempt that we're interested in. So I'm going to select that one. And I'm going to repeat that for every other student, right? So we're only interested in the attempt that resulted in the longer distance. So student 2, 5.8, student 3, 4.9, student 4, 4.7, student 5, 5.1, student 6, 5.7, student 7, 5.6, student 8, 5.3, student 9, 5.5, student 10, 4.5, and student 11, 5.9. All right, so now we know that we're only interested in the numbers that are in the red circle, and we basically now have to find the one that was the 5th highest. Okay, so 5th, I like to work down from first. So what we'll do is let's find the highest number, and that would be the 5.9 over here. Right, that's the longest recorded jump. So we know that student 11 was first. So I'm just gonna write that there, and let's just work our way backwards to 5th. Okay, so who got this second highest attempt? That would be student 2. They recorded 5.8 meters, so they're second. Then student 6 recorded 5.7 meters, so they're third. Student 7 recorded 5.6, so they're fourth. And student 9 recorded 5.5, and that's going to put them as 5th. So we know that student 9 is the person who recorded the 5th longest jump, and so therefore they're 5th in the competition. So therefore the answer should be C. Let's move on now to question 5. All right, so question 5. This is a classical example of a critical reasoning question. And in this particular type, it's actually known as assess the impact of additional evidence. Okay, so I'm going to write that for you guys. So this is an example of a critical thinking skill question. And the particular type is known as assessing the impact of additional evidence. Okay, so what does that mean? It means that you're given an argument, okay? So these types of questions always start by giving you some sort of argument or some sort of conclusion, and then the answer options will then ask you to find a statement that in this case most weakens the above arguments. Sometimes it strengthens, in this case it is weakens, okay? So what we need to do is let's start by reading the question and then we'll go through the strategy. So question 5 says, Gabriella says that zoos should be banned because it is wrong to keep wild animals in captivity. She says that animals should have the right to live in their natural habitats. Which of the following statements, if true, most weakens Gabrielle's argument? Okay, so first step, guys, is to break down the given argument. What you should do is generally draw a little flowchart. That's what I like to do. Because sometimes if you just read it as sentences, it's easy to lose track of the logic and the argument. So it's nice to draw it in a flowchart. So I like to draw the argument into a flowchart. All right, so let's have a look. Why does Gabriella say that zoos should be banned? It's because so the first step is to draw the argument into a flowchart. So let's have a look. It says that Gabriella wants says that zoos should be banned, and the reason she gives is because it's wrong to keep wild animals in captivity. They should have the right to live in their natural habitat. So if I was to write that, I might just write something like wild animals have the right to live in their natural habitat. And that's why zoos should be banned. That's why we should ban zoos. Right? So she's giving us a reason why she thinks that zoos should be banned. It's because, you know, these wild animals, they should have the right to live in their own houses and habitats. So now the second step, and it's an important step still, is to actually figure out what the question is asking us. Is it weaken or strengthen? Okay, that's pretty important. So we know that in this question, it wants us to choose something that weakens Gabriella's argument. Okay, so we want to choose something that weakens the argument. And remember, Gabriella's argument is that we should ban zoos, right? And so therefore, if something's going to weaken the argument, it should be something that says that zoos shouldn't be banned, right? So I like to think of it like in either like it's either going to be positively reinforcing the argument or negatively reinforcing the argument. So if it's going to be weakens the argument, we need to look for an answer option that says something like zoos should be kept and or zoos should not be banned. Okay, so zoos should be kept for a particular reason, or they should not be banned. Okay, and very importantly, something that's going to weaken Gabriel's argument has to actually attack this logic. Again, it has to attack the logic of her argument. So this bit here, okay? So let's keep that in the back of our minds as we read through our answer options. So remember, again, we're looking for something that weakens the argument. So it should be something that says that zoos should be kept. And it should also be a statement that attacks the logic of Gabriella's argument. So let's look at option A. Option A says zoos provide an opportunity for humans to see wild animals without having to go on safari. So again, like I said, simplify it. Is option A saying zoos should be banned or zoos should be kept? It's saying that zoos should be kept, right? Because it allows humans to see wild animals without having to go elsewhere. Now, so I might just put a dash next to option A because it is something that does weaken Gabriella's argument, since it's saying that zoos should be kept as opposed to banned. But it's not really attacking the logic of the argument. It's not really talking about how wild animals have the right to live in the natural habitat, that sort of thing. So let's just keep it as a neutral answer right now. It's not something that I'll cross out. Option B, let's have a look. Modern zoos try to ensure animals are given some exercise and stimulation. Okay, option B is also kind of saying that zoos, it's not saying that zoos should be banned, right? It's kind of saying that zoos try and give animals some exercise and stimulation. Now, in this case, I would say that it's kind of irrelevant to our argument. It's not whether saying zoos should be kept or banned. It's just saying, it's just telling us the fact that zoos give animals exercise and stimulation. So I would actually cross out answer option B because it's irrelevant to the actual argument. The argument is whether zoos should be banned or not. Okay. And then option C says some wild animals would die out completely if they were not bred in captivity. Okay. So option C is saying that, you know, we should definitely keep zoos because if we didn't have zoos, some of the wild animals would be extinct, would become extinct if they were in the wild by themselves. So that is definitely something that is going to weaken Gabriella's argument, okay? Because it is trying to say that zoos should be kept. So again, I'm going to put a dash next to it, right? Because it's a potential answer that weakens Gabriela's argument. Then let's look at option D. Wild animals kept in confined spaces can explain extremely distressed behavior. Now, option D is something that strengthens Gabriela's argument, right? Gabriela's trying to say, we need to ban zoos because, animals have the right to live in their natural habitats. D is saying, if you keep animals in zoos, they get really anxious and stressed. So it's also trying to say we should ban zoos. So it's actually agreeing with Gabriela, and it therefore strengthens it. And so therefore, we can cross D out since it's actually doing the opposite of what the question is asking us for. It's actually strengthening the argument. Now, this brings us to a scenario which is very common for these types of questions. You basically narrow it down to two options that both kind of weaken the argument, okay? Now, the tricky thing is you need to find the one that most weakens, right? Most weakens, as you can see in the question at STEM itself. And the answer option that would most weaken Gabriela's argument is something that attacks its logic, okay? So that's what I'll tell you in the third step. To find the best answer, the answer option must attack the provided argument. Okay, so let's have a look. Between A and C, which one do you think actually attacks the logic of Gabriela's argument? Well, let's have a look at option C in more detail, okay? Remember, Gabriela is saying that we should ban zoos because wild animals have the right to live in their natural habitats. Now, option C is saying some of these wild animals, they would just die by themselves in the wild, yeah, if they weren't bred in the captivity of a zoo. So doesn't that, if they were already dead in their natural habitat, then Gabriela's argument is kind of completely obsolete or unnecessary, since we already know the wild animals, they would die by themselves in the wild. Therefore, it doesn't even matter whether their rights are met within zoos. So option C definitely attacks the logic in Gabriela's argument, since they would already be dead in their natural habitat, right? Some of these animal species. So therefore, option C is the better one between A and C, okay? And it's the one that most weakens or attacks the logic in Gabriel's argument. Okay, let's now move on to question 6. So in question 6, we now have a information provided in the box. Again, this is a type of detecting reasoning error question. So if you remember from the previous one we went through, there's a given scenario again. Now, 2 people have made a conclusion based on this, and then we now have to choose whose conclusion is correct. Okay, so let's have a read. The beruga lizard and Indora lizard are very similar. The only major difference between the 2 species is their diet. Berugas mostly eat termites and ants, but they will occasionally eat other insects, and even things like snails. So we know that berugas eat termites, ants, other insects as well. Indoras will eat almost anything if they are hungry, and they especially like termites as well, but they pretty much eat anything, but they never eat ants. In fact, ants are poisonous to Indoras. Kiera and June have rescued an injured lizard, and they want to find out which species it is. Okay. So the way I like to do it, first of all, is to, again, represent the given scenario into a little flowchart to make things easier. So we know there's 2 types of lizards. There's the beruga lizard, and there's also the Indora lizard. Now we know that both these species, they like to eat termites. Right? Because it says that Belugas eat termites and ants and other insects as well. Indoors also really like termites. The one thing that they are different in is ants. So we know for ants, belugas will eat them still, right? So we'll write a big yes here. But we know that indoors, they never eat ants. So we'll write a big no here because the ants are poisonous to them. Okay, so now that we're armed with this information in a diagram or flowchart, let's read through Kiera and Jun's statement. So Kiera says, if we only feed it termites, we'll be no closer to knowing whether it's a beluga or an indora. So now let's assess her reasoning. Based on our flowchart, we know that termites are eaten by both beluga and indoras. So if you do give this unknown species a termite to eat and they eat it, then you're no closer to finding out whether it's beluga or indora, since both of those species would eat it. And therefore, Kiera's statement is correct. So let's give that a tick. Now let's look at Jun's statement. Jun says the only way we can know for certain would be to give it some ants. And so let's look back at our diagram. We know that belugas will definitely eat the ants and indoras definitely won't. So if we gave this unknown lizard ant, then we'll be able to find out for certain what type of species it is, whether it was beluga or indora, based on whether it eats the ant or not. So again, Jun's statement is also correct, right? By giving it an ant, we'll be able to figure out whether it's a beluga or an indora lizard. So Kiera and Jun are both correct. So therefore, C is our best answer. Let's now move on to the next question, which is question number 7. So let's have a look at question number 7. In question number 7, it says, plots of land within a community garden are allocated for people to grow fruit and vegetables. The plots come in a variety of sizes. The garden consists of 7 plots as described in the table below, and it gives us dimensions of the plots in length and width, okay? And then the question is now asking us, which one of the plans below could show the plots in the diagram? For each plot, the length is the longest side and the width is the shortest side. And then you can see we have different diagrams of how the plots are arranged in the answer options. So you might, when you start off by looking at this question, you might feel like, oh, wow, there's a lot of information that's given in numbers here, and there's a lot going on in these diagrams. What you want to do is look for trends within the information, okay? So this is what I call a problem-solving type of question that's known as identifying similarities. So problem-solving question, and this is known as identifying similarities. And what that means is the strategy or the approach to doing this question is to look for trends, okay? Look for common trends and patterns. So let's have a look at the actual table that we're given. We notice that when you start by looking at it, you notice plot 1 has a length of 4 meters and a width of 4 meters. So the length and the width are the same. What does that mean, guys? That is a square, is it not? Right? A square has both the same length and width. Okay, then we go on to look at plot number 2. Again, we notice that it is a length of 4 and a width of 4. So again, it's a square, and both plot 1 and plot 2 should be the same square size. Okay, so what I'm going to write is we should look for a diagram. Oops. We should look for a diagram that has 2 identical squares. Okay, and let's just continue on. What we also notice is plot 3, plot 4, and plot 5, they all have the same dimensions, 6 by 3. So now we know that we should also look for a diagram with 3 identical rectangles. And then lastly, if you draw your attention to plot number 7, which is 6 by 6. So we should also expect a larger square, right? There's one larger square. And that's going to be enough information for us to work with, okay? So now when we look at these diagrams, we know exactly what we should be looking for, right? When we look at our answer options, we know that we should be looking for one with 2 identical squares and a one larger one, and also one with 3 identical rectangles. And what you want to do is just be systematic about it, okay? So squares are probably some of the easiest shapes to identify. So we'll start off with that. So now let's go through our options A, B, C, and D and see if we can find one that has 2 identical looking squares and also one larger square, guys, okay? So let's have a look at option A first. In option A, what do we notice? I notice there's a square here and there's a slightly larger square here, but I don't notice 2 identical small squares, right? There should be a total of 3 squares altogether. So therefore, I already know that option A can't be possible, right? Because we're looking for a diagram with 3 squares. So now let's look at option B. In option B, what do we notice? We notice, oh, this is a good start. We've got 2 identical squares here, okay? But where is that one larger square? You might say this one, but it's actually not a square. This is still a rectangle if you look very closely. So again, option B can't be our answer because we've only got 2 identical squares. We're missing that one larger square. So again, I'm going to cross B out. Now let's move on to C. In option C, we see 2 identical squares here. And voila, we also see that one larger square there. Okay, so we know that option C is potentially our answer. And remember what I said, you always look through all your options before you choose it. So now let's look at option D. So in option D, what do we notice? We notice there's 2 identical squares here. I also notice 2 identical squares that are a little bit larger. And I also notice one larger square here. So there's 5 squares in total in option D. But we're only looking for 3. Remember that? So therefore option D can't be our answer option because we're only looking for 3 squares. And you can see in option C, there's 3 squares in total. And if you want to just be safe, you can double check for the 3 identical rectangles that should also be in there. And you can also see that clearly there's a rectangle here, a rectangle there, and a rectangle here that look identical. So therefore, option C should be the best answer here. Let's keep on going. So now let's look at question 8. Question 8 says, you arrived at school this morning and saw the sports coach opening the sports hall. The cleaner opens the hall every day except Sundays and Mondays, when the hall either remains closed or is opened by the sports coach. The sports coach is only there for training and for competitive events. The hall is reserved for training in the mornings and events in the afternoon. The sports coach always arrives 15 minutes early for both training and events and schedules them to make sure they do not occur on the same day. Which one of the following sentences must be correct? Today is Sunday is option A. B, the hall is open for training today. C, there is a competitive event today. And D, the cleaner is unexpectedly away. So what I will do is start off by analyzing the information that's given, and that's all in this first sentence here, okay? It tells you that you arrived at school this morning, so we know it's morning, so I'll circle that, that's important. And we know that we saw the sports coach opening the sports hall. Okay, so with approaching a question like question 8, you want to identify the key words in the question first, just by either underlining them or circling them like I have. Okay, so far we've already established that the sports coach is here. So it must mean that it's either a Sunday or Monday. It's either Sunday or Monday, simply because the cleaner opens the hall every other day, right? So if the sports coach is here on a morning, so I'll write that here, sports coach, and it's morning. What can we establish? We know that it's either going to be Sunday or Monday. So I'll write that here, Sunday or Monday. We also know that the hall is reserved for training in the mornings. So we know that since it's the morning time when we see the sports coach opening it, it actually must be for training. Okay, so what we know right now is that some sort of training is happening, but we can't tell whether it's Sunday or Monday. Well, there's not enough information to figure that bit out. So let's look through our answer options again. Which of the following sentences must be correct? Option A says today is Sunday, which we can't say for sure is true. Right? We just know that it's either going to be a Sunday or Monday. We don't know exactly which day it is. So option A, we can't say must be correct. B says the hall is open for training today. And that much we can establish as we have, because we know that training occurs in the morning when the sports coach opens it. And that is what's happened. So therefore, B is definitely one of the potential answers. Okay, and it's actually the one that we can establish first. Like I said, we always got to rule out the other answer options as well. C says there is a competitive event today. Again, if there's a competitive event, the sports coach would be opening it in the afternoon. So again, you know for sure C is not correct. And then D is a bit of an irrelevant option. The cleaner's unexpectedly away. That's kind of like, it's a red herring there, guys. You can't just assume that the cleaner is going to be away. You have to make your answer based on the information that's given. So therefore D, we should cross out, and hence B is our best answer. Let's now move on to question 9. So in question 9, we have, again, one of those detecting reasoning error questions. And we already remember the approach. We read the scenario, draw a little flowchart, and then assess the actual statements. So let's have a read. Because of all the trees around it, the waterfall at Blank's Point can only be seen from 2 places, Dwada's Crossing or the lookout across the valley. It's been impossible to get to the lookout since the rope bridge fell down 2 months ago. Okay, so what I'm going to do now is, again, draw this little information in a diagram. Okay, so we know to see the waterfall, there's 2 ways. There's 2 places that we can see the waterfall. It's going to be to see the waterfall. There's 2 options. You can either see it from Dwada's Crossing, or you see it from the lookout across the valley. Now, there's one condition. To view the waterfall from the lookout, you needed to have gone there 2 months ago, right? Because we know that the rope bridge fell down 2 months ago and no one's been able to get to the lookout since, right? So in order to view the waterfall from the lookout, there is a condition that you needed to have gone there at least 2 months ago. So that's just a greater than sign there. So at least 2 months ago. And then Dwada's Crossing, nothing's wrong with that. So you can see the waterfall from Dwada's Crossing anytime. All right, so with that flowchart in mind, now let's assess Ivy's statement. Ivy says, I remember seeing the waterfall about a month ago, but I can't remember where I was. It must have been Dwada's Crossing. So now let's look at Ivy's statement and put it into our little flowchart. She went to see the waterfall about a month ago. So if she saw it about a month ago, the bridge would have already collapsed. Yeah, since the bridge collapsed 2 months ago. So therefore, she couldn't have seen it from the lookout. She must have only been able to view the waterfall from Dwada's Crossing. And therefore, Ivy's statement is indeed correct. Her reasoning is correct. Okay, now let's move on to Annie. Annie says, my brother did a beautiful painting of the waterfall from the lookout. That must have been more than 2 months ago. Again, let's assess Annie's statement in our flowchart. So the brother did a painting of it from the lookout, and Annie says it must have been more than 2 months ago. which is satisfying this condition. Remember, we said that in order to see the water from the lookout, you must have gone at least 2 months ago. And Annie is saying that her brother must have been more than 2 months ago when the brother went. So therefore, Annie's statement is true as well. So as you can see, both Ivy and Annie were true. So therefore, the best answer here in this case is C. All right, let's keep going. So now we have question 10. Let's have a read of it. Question 10 says, Mr. Jackson has a large room which can be hired for children's parties. He has a time limit of 4 hours, and the room can accommodate a maximum of 25 children. His charges are detailed in the following table. Okay, and then our question says, what is the cost per child for a party lasting 2.5 hours for 12 children? Okay, so let's just remember the key bits of the information from the questions then. We know the party lasted 2.5 hours, and we know that there were 12 children. Now let's look at our little table. So the table has the time, how long you want to book the party for, and also the number of children who will be present. Now, again, it's one of those relevant information questions. A lot of the information here is not needed to answer the question. So let's just get rid of the things that we are not interested in. So first of all, we know the party lasted 2.5 hours. Okay, so we're only interested in this row. Okay, everything else we don't care about. So I just cross it out. Okay, and we also know that it's for 12 children. So that would be in this category there. So we're not interested in any of these numbers, or these ones, or these ones. Okay, so in particular, we're looking for this number here, right? We know that for 2.5 hours for 12 children, it's going to cost you $171. And if we want the cost per child, we simply need to divide 171 by 12. It's just a bit of long division. So 12 goes into 17 once. So we just go 17 minus 12, and that's a 5. We bring down the 1, and that's 51. And then 12 goes into 51 4 times to make 48. And there's a remainder of 3. Now, if you were short on time, you can already begin to choose your answer, because you know your answer is going to be 14 point something. And the only answer option that has 14 point something is D. But for the sake of today, we're going to go through the whole solution. So we're going to put a decimal point, and we're going to add the extra 0 down there. And then we know that 12 goes into 30 twice. That gives us 24, a remainder of 6. And then you bring down the 0, and therefore 12 goes into 60 5 times. So you get $14.25, confirming your answer of D. Okay, guys, let's now move on to question 11. So let's have a read. It says, 4 online shops, Hughes Homes, KX Hi-Fi, Brennan Audio, and Roberts Electricals are all selling the same model of television, but at different prices. Nathan needs to get one as quickly as possible, so I'll underline that, but can't afford the most expensive. KX Hi-Fi takes longer to deliver than Brennan Audio, but is faster than Roberts Electricals. Roberts Electricals is cheaper than Brennan Audio. KX Hi-Fi costs more than Brennan Audio, but is cheaper than Hughes Homes. Which of the 4 shops will Nathan choose? Again, it's one of those questions, those problem-solving questions where you need to draw the information in a diagram. Because then you can visually summarize it all into one diagram, and it's much easier to find the answer. So what we're going to start with is by drawing a little flowchart of the speed. We do know that Nathan wants to get one as quickly as possible. So speed is the most important condition, and we just know that he can't afford the most expensive. Okay, so what I'm going to do is I'm going to draw speed here, and I'm going to have the slowest here and the fastest here. All right, and we can have price on the side as well. So this is going to be the cheapest. And this is going to be the priciest. So most pricey. Okay. All right. And it's going to go down like that. Okay. So let's now populate our diagram with the information from here. So we know KX Hi-Fi takes longer to deliver than Brennan Audio, but it is faster than Roberts. So from that sentence, we know that Roberts would be the slowest, okay, out of the three. So I'll write Roberts here. And then we know that KX is faster than Roberts, so we'll write KX next. But KX takes longer than Brennan. So Brennan is a bit faster than KX. And that's all we gotten so far. We don't know where Hughes Holmes is in the speed department. Let's move on to the next sentence. It says Roberts Electricals is cheaper than Brennan Audio. So I know that Roberts is cheaper than Brennan. Okay. Next sentence. KX Hi-Fi costs more than Brennan. So I know KX is going to be pricier than Brennan, but KX is cheaper than Hughes Holmes. So Hughes Holmes must be the priciest. Okay. All right. So it would go in order like that. Okay. So remember, we want the one that delivers as quickly as possible. So which one is the one that delivers as quickly as possible? From our speed diagram, we know that has to be Brennan. And then let's just look at the price. Brennan is the second cheapest. So it's definitely not the most expensive. So Brennan is quite frankly satisfying both these conditions. It is the one that's going to be delivered the fastest based on the information we're given. And we also know it's not the most expensive. So it satisfies all criteria, and therefore Brennan would be the best answer option here. And we actually know that Hughes can't be the answer option because Hughes is the most pricey over here, as you can see. So even though we don't know the speed of delivery for Hughes, and since we know it's the most pricey one, we know that Nathan can't afford it, and therefore it can't be the answer option. Great, let's keep going. Now let's look at question 12. So it is one of those detecting reasoning errors again. So let's have a read. We know that there are two different species of frog are known to live on the Quilpie Nature Reserve, speckled greenbacks and red sentinels. Ahmed and Melissa are investigating the populations of the two species and have done an experiment. So let's have a look. Ahmed says, for a whole year, every time a frog was spotted on the reserve, we made a note of which species it was. Over the year, we recorded 113 red sentinels and only 15 speckled greenbacks. And then Melissa says, this tells us that red sentinels are much more common on this reserve and speckled greenbacks are quite rare. Which one of the following sentences shows the mistake that Melissa has made? Okay, again, remember, the best way probably is to always draw a diagram. So that's exactly what we're going to do. I'm just going to draw the diagram beneath. So we basically, what we want to do is draw a little flowchart of Melissa's argument. So she's basically arguing that since we know there's 113 red sentinels and only 15 greenbacks, based on these numbers, she's concluded that red sentinels are more common. Okay, so I'll just write that out. So there's 113 red sentinels, and there is 15 greenback. And based on this data, Melissa has now concluded that red sentinels are more common. So now we need to figure out one of these answer options from A, B, C, D has to either break this logic, okay? Might use a different color to show that. Okay, so they break the logic of Melissa's conclusion. Okay, so let's have a read through our answer options. It says that A, just because red sentinels are more common in Quilpie does not mean they are more common in other places. Now, Melissa has actually just said they're more common on this reserve. So Melissa actually hasn't made the assumption that red sentinels are more common in general. So therefore, answer option A is incorrect. She hasn't made that mistake actually, so we have to cross it out. B says there may be other species of frog on the reserve that have not been discovered yet. That is quite irrelevant to her argument. Her argument is simply because, oh, we've got these numbers, and based on these numbers, red sentinels are more common. So there's nothing about other species. So this is an irrelevant answer, option B. Irrelevant. Then answer option C says, seasonal changes in weather may affect the two species of frogs differently. Sure, that might be true, but it's not actually a mistake that Melissa has made. It's not, we haven't really talked about the seasonal changes at all. So again, it's quite irrelevant to the argument here. And that leaves us with answer option D, which says that red sentinels may be easier to spot than speckled greenbacks. Now, answer option D breaks the logic of Melissa's argument because it actually provides another reason why red sentinels are more common, and that is because they're easier to spot. Okay, so red sentinels are easier to see. And that may explain, that might explain why you have this data, okay? It's not the fact that sentinels are more common, that's why you see 113 of them. It might be because they're easier to see. And, you know, just to make sure the answer makes sense for you guys, let's just consider an example, a hypothetical situation. What if there were 200 greenbacks that you didn't spot? And that is definitely something that could be the case and would and this is definitely showing you a potential assumption that Melissa has made, right? She's made the assumption that red sentinels are more common based on the numbers that they saw, but it could easily have been the case where it's hard to see the green ones, and there's actually 200 that you didn't spot, and therefore this makes her conclusion quite incorrect. So therefore, our best answer option is D. Okay, so you can see that option D provides an alternative explanation to why there's, you know, why they got these particular numbers here. Okay. Okay, moving on. Let's go on to question 13. Question 13 is another example of one of those visual spatial reasoning questions. So I'll just make a little note of that. Visual spatial. Reasoning questions. It's saying there's a piece of puzzle is shown below. Which one of the following pieces will fit with the piece above to make a complete cube? So there's several ways you could approach this question. But the first way would just be an elimination approach. And you generally, as a tip for these types of questions, is to start off with a bird's eye view. Okay, so that's what we're going to do. So if we look at it from the top, right? So pretend that this is an eye. All right, and we're looking at the shape from the top. What would we see? So the bird's eye view would show us a little sideways T, wouldn't it? Show us something like this. Okay, and in order to make it a complete cube, that means what I'll draw this in blue, guys, is the other piece of the puzzle has to, you know, make it a cube. So it has to look like something like this, right? And that's from the top view as well. So it looks like a little a C shape, right? Now, if you look at our answer options, all right, the only one that's not a C shape from the top, all right, is actually answer option D. Answer option D is only an L shape. Yeah. So therefore, I already know we can cross out answer option D. Right? Simply because the bird's eye view does not show a C shape. So that's the first step. The second step, guys, so if we call this our first step, that's that, we can remove answer option D. From our second step, we should focus on the sloped surface. So I'm just going to shade that blue over here, right? So we know that the sloped surface starts from the top and it ends actually a little bit above the bottom. Can you see that it doesn't go all the way to the bottom? So in order to find the piece of the puzzle that will fit into that, we're also looking for a sloping surface that doesn't go all the way to the bottom, right? Now, if you look between the answers option A, B, and C, you can see that in option A, the sloped surface doesn't go all the way to the bottom, so it satisfies that. Same with C, but unfortunately, with B, you can see the sloped surface goes all the way to the bottom, and therefore it wouldn't fit in with the piece of puzzle. So therefore we can exclude B now. And that leaves us A and C. And with A and C, the last thing that we should look at is simply the actual orientation. So step 2 was looking at the sloped surface. Step 3, we should look at the orientation. So what do I mean by this word orientation? It's simply whether after we rotate the shapes A and C, do they actually fit in? Okay, so if you have a look at our answer option C here, if we rotated this clockwise, right, then this sloped surface here, after you rotate it clockwise, would match perfectly with the sloped surface here, right? These two would match if we rotate this, yeah? But in answer option A, this sloped surface here, it can't actually fit into there. It doesn't actually fit, right? It's actually, it's been flipped. And when you rotate this one clockwise, the sloped surface would be on the bottom end and it wouldn't fit in with the sloped surface in the given piece here. Okay, so that means the answer has to be C. Okay, because after you rotate this little shape clockwise, this one will match perfectly to this side here, and the rectangle would match perfectly to the rectangle here. But everything will be flipped for answer option A and it wouldn't work. And so that's how we arrive at the answer C for question 13. All right, let's now move on to question 14. What I'll do is just zoom in a little bit. All right, and so let's have a look at this question 14. It's again one of those assessing the impact of additional evidence. Let's have a look. Leo and Nicole are discussing dramatized violence on television. Nicole says that it is harmless because it is not real violence. Leo replies, that is obviously untrue. What people see on television influences their attitudes and their behavior. Violent programs can have serious consequences. Which of the following, if true, most strengthens Leo's argument? So remember, the strategy for this question is to first summarize the arguments or the conclusion in a flowchart. And that's exactly what we're going to do. So we know that Leo is saying that violence shown on TV, so I'm just going to call that TV violence. Leo says that it can definitely influence people's behaviors and attitudes. So I'm going to write TV violence influences attitudes and behaviors. And then he goes on to say that this can have serious and harmful consequences. So it can have harmful effects. Right. So to summarize, TV violence can have harmful consequences on people by influencing their attitudes and behaviors. So it's very nice that we can summarize this whole paragraph into this little flowchart here. Now let's answer the question itself. we are looking for a statement that strengthens Leo's argument. So again, I like to simplify things, guys. If we're looking for a statement that strengthens Leo's argument, really we're looking for something that says that TV violence does have harmful effects or it is bad, yeah? So TV violence is harmful or bad. Something that supports that kind of saying or that argument. Right, so let's have a look at option A first. It says, violence is a fact of life and banning it on television won't stop it happening. So remember, we're trying to strengthen the argument that TV violence can have harmful effects. It's not really whether, banning it on TV will stop it from happening. So option A is kind of irrelevant to the argument, okay? So we're gonna cross it out because it's irrelevant. It's not really, supporting the fact that TV violence can lead to harmful effects. It's simply saying, banning on TV won't stop it from happening. It's a bit irrelevant. Let's have a look at option B. Option B says, seeing violence on TV can help people understand its consequences. Okay. Now, option B is saying, if you see TV violence, it can help them understand the effects. But Leo's argument is saying that TV violence can influence behaviors and therefore lead to harmful effects. Again, it's whether it can help people understand the consequences is a bit irrelevant because Leo is trying to argue that seeing violence on TV can lead people to, seeing violence on TV can, lead to changes in people's attitudes and behaviors and therefore lead to harmful effects. It's not really about whether it can help people understand the consequences. So again, answer option B is irrelevant. And then let's have a look at answer option C. Television advertising is very effective in influencing people's behavior. Now, this one is saying that anything that's on TV, whether it's advertising or whether it's a TV show, it's very effective at changing people's behavior. So you can see it's strengthening this part of Leo's argument. What I would say is having a strengthening effect there. It's really saying that anything that you see on TV can really affect your behavior. TV violence being one of them, it can affect people's behavior. So you can see that C does strengthen Leo's argument here, right? Especially the first part of his argument. So we're gonna keep C as one of our potential answers. And let's just have a look at D. D says that people who don't want to see violent programs don't have to watch them. Again, that's quite irrelevant, right? We're trying to say that TV violence can influence your behavior and lead to harmful effects. Whether you don't like violence, so you don't have to watch it, that's quite irrelevant to the argument. So therefore, our best answer option here is C. Let's keep on going to question 15. Now, in question 15, we're given, again, one of those detecting reasoning error questions. So let's have a read through the scenario. It says the Tame family are planning a day out tomorrow. They will decide where to go based on the weather in the morning. There are 3 possibilities. If it's sunny, they'll visit their aunt who lives by the beach. So again, I'm going to start writing this information into a flowchart, okay? So we know that there's 3 options. If it's sunny, they're going to go to the beach, or they're going to visit their aunt who's next to the beach. And then if it's raining, they're going to the indoor market to do some shopping. And if it's overcast, but not raining, so it's just a gray, dreary day, if it's overcast, we know that they'll head into town. They might still go to the indoor market, but they definitely won't go to the beach. So we know they'll go head into the town and they may, question mark, go to the indoor market. But definitely not the beach. Okay. All right, so we've already represented the scenario into a flowchart. Let's read through these statements by Victor and Aiden. So Victor says, if you see the tangs in the indoor market tomorrow, it must mean it's been raining. Now, let's have a look. We know that, yes, if it's raining, they will go to the indoor market. But we also know if it's overcast, there's a chance they're at the indoor market. So Victor's statement is not true because if they're in the indoor market, it could either be raining or overcast, okay? So that's why Victor's statement's incorrect. Let's look at Aiden's statement. Aiden says, if you see them at the beach, it must mean the weather forecast was correct. And what exactly was the weather forecast? The weather forecast for tomorrow morning is for sunshine, okay? So if you see them at the beach, it must mean that the forecast was correct and the forecast said it will be sunny, and that is correlating with our flowchart. We know that if it's sunny, they're going to be at the aunt's place, which is next to the beach. So if we do see them at the beach, it means that it was sunny and therefore the weather forecast was indeed correct. So therefore Aiden's statement is true, and that means that option B has to be our answer. Okay, guys, let's now move on to question 16. So in this question, let's have a read of it. It is actually another example of a relevant information question. So we should just discard the information that's irrelevant and focus on the information that is relevant. Let's have a read. The table below shows the list of classes available each day at a summer school. Each student must take one class each day. The class can either be in the morning or in the afternoon. And we're given a timetable of the different classes on each day. And we know that Zach has chosen classes in art, geography, maths, English, and history. He wants to have Friday afternoon free. And our question is, on which day must Zach do geography? So like I said, one of the best ways to approach these types of questions is just to get rid of the information that you don't need to know or care about. So we already know that Zach wants to have Friday afternoon free. That means he won't be taking any of these classes, right? So I can just draw a big X through that. And we know he's only interested in art, geography, maths, history, and English. Now, remember, he needs to take a class on each day. So if he's not taking a Friday afternoon class over here, he has to be taking one of the classes in the morning. And we already know that he's not interested in economics and sports. It's not part of those classes that he wants. So that means the only choice he has for Friday morning is art class, because he's not interested in economics or sport. With that in mind, we should now go through the timetable, and it won't take us too long. And we should just cross out anything that he wouldn't be interested in, right? So we know he's not interested in economics. I'm going to cross out all the economics. Okay. We also know he's not interested in science. So let's get rid of all the science. He's not interested in digital tech. So let's get rid of that. Well, he's already chosen art class, right? So we can also get rid of all the art classes. He's not interested in sport. Let's get rid of that. Not in digital technology, not in science, and not in sport. Okay, so that removes a lot of the information, yes? And now we can just focus on the subjects that he's interested in, okay? So first of all, this is still about pattern recognition to an extent. You notice that he wants to do a class in English, right? He wants to do an English class. And from the timetable that's left over, there is only one class for English, which is the Monday afternoon. So he must take this class. So we'll circle that. It actually means he can't do geography on Monday. Similar thing, we notice that he wants to do history. There's only one history class. It's on Tuesday. So he must therefore take history here, and he can't do geography then. which means the only geography class that he can attend is the one on Thursday afternoon. And so we are going to circle that, and that must be our answer. So Zach must do geography on Thursday. And just for completeness sake, that means on Wednesday, he has to do maths. Okay, excellent. Let's move on now to question 17. Now, this one is a bit of a trickier one. So let's have a look at the question. It says that Gabby and Luke want to use a code to send secret messages to each other. In the code, each letter of the alphabet is represented by a one-digit number as follows. So that means each letter of the alphabet has a particular number associated with it. Just notice though that there are multiple letters associated with the same number. So just to give you an example, A is represented by 1, but so is K, and so is U. All right, so just keep that in the back of your mind as we do this question. And they've given us an example, so we can see that Bell would be written in the code as 2522. And we can just confirm that. So B is 2, E is 5, and L is 2 again. Right, and so that would make sense. So let's keep on reading. To test the system, Gabby writes 4 words in the code and sends them to Luke. Luke tries to decode them and gets the following answers. These ones here: took, done, high, and sort. Luke is confident that he has 3 of these words correct, but he is unsure about the other one. Which word is Luke unsure about? So it's a bit of an interesting question because it's asking you which word Luke is unsure about. What that actually is asking us for is, are there any sort of codes that could translate to multiple words? Remember how I said that if you had the number 1 as a code, it could actually refer to multiple letters. It could refer to A, it could refer to K, and it could refer to U. Right? And so that could cause a bit of confusion, because if I gave you the code 1, you might not necessarily know which letter I'm referring to, right? And that is what they're kind of asking with this question, right? So basically what we need to do is we need to first translate all these words back into their codes, and then we're going to look for a code that might be the most confusing one. Okay, so let's start off with took. Now, took is spelled as, is coded as 0. O is 5, so 5, 5, and K is 1, so it's 0, 5, 5, 1. And let's just do that for all the other ones as well. So done is 4, 5, 4, 5 as well. High is 8, I is 9. G is 7 and H is 8. And then sort is 9, 5, 8, and 0. Okay, so now you've translated all the words into the original codes. And basically our job now is to figure out which one of these codes could be the most confusing to actually translate into a word. So what we should be looking for are numbers that occur very frequently, or the most frequently, in this diagram here, okay? So I'll give you an example. Let's have a look at 0, okay? How many times does 0 occur? It represents J and it represents T. So there's only 2 possible letters that 0 could mean, okay? Now, on the other hand, let's look at something like 4. Oops. 4. So how often does 4 occur? And I'm going to do that in red, guys, okay? So 4 could be D. It could be N, but it also could be X. And just for example's sake, let's also look at 5. 5 could be E. It could be O. It could be Y. So you can see that the number 4 could represent D. It could represent N. And it could also represent X. The number 5 could also represent 3 different letters. It could be E, it could be O, and it could be Y. And now I will save you the trouble. All the other kind of numbers here, like 1, 8, 9, 7, all of these won't have as many different letters that they could represent. It might just be 2 different letters that it could represent. But you can see that 4 and 5 might be the most confusing because both 4 and 5 represent 3 different letters, potential letters. So if you really think about it, just from an eyeball perspective, this code here would be the most confusing one for Luke to decode, because there could be like many different combinations of letters that 4545 could represent, right? Whereas something like 0551, there's going to be less word combinations it could represent, same as 8978. And so, there's no way you can like try and figure out all the different words that all of these codes could represent in the actual test. So you have to use a bit of intuition and logic here. And you can tell that 4545 might be the most confusing one, since there's so many different letters that the numbers could represent. And just for an example, we already know 45 could actually mean another word like node. So 4 could also mean N, 5 can mean O still, 4 can then mean D, and 5 can then mean E. And node is another word that could be translated from the code of 4545. And so therefore, on the test day itself, with the time pressure, you will have to make a logical deduction here, and it would be that done is the most confusing one to translate, and therefore Luke is going to be the most unsure about that one. Okay, now let's move on to question 18. So in question 18, what do we have here? We've got another one of these detecting reasoning questions, okay? And it says, to be able to go to the school excursion, permission slips must be handed in by Friday. There are only 50 places available, and these are allocated to the first 50 students that hand in their permission slips, okay? So I'm going to draw this scenario actually into an equation. We know that to get a place onto the school excursion, you need to satisfy 2 conditions. You need to be the first 50 to hand it in, plus you need to hand it in by Friday. And if you are in the first 50 and you hand it in by Friday, you are guaranteed a place on the excursion, right? You get a place on the excursion. But you need to satisfy both these criteria, right? Criteria 1 and criteria 2. So now let's have a look at our statements by Megan and Kate. So Megan says, I've already handed in my slip, so I'll definitely get a place in the excursion. Now, Megan's statement is not very specific. All we know is she's handed in her slip. We don't even know if she handed it in by Friday. We don't know if she was the first 50 to hand in. So she cannot be sure to get a place in the excursion. There's not enough information for Megan's statement to be correct. So therefore, Megan's statement, since it has not explicitly satisfied those 2 conditions, she has made an incorrect statement here, okay, or conclusion. So now let's have a look at Kate's statement. She says, I won't be able to hand in my slip. I won't be able to hand my slip in until Friday, so I won't get a place on the excursion. So Kate says she won't be able to hand in her slip until Friday. Therefore, she won't get a place on the excursion. So first of all, Kate hasn't even mentioned anything about, whether she was in the first 50 to hand it in. Again, you're not completely sure whether Kate won't be able to get a place in the excursion. She says, I won't be able to hand in my slip until Friday. So on the day of Friday, she might have handed in her slip, and she could have still been the first 50 to hand it in. So she's not it's not an absolute guarantee that she won't get a place in the excursion. There is a chance that she hands it in on Friday and she's the first 50 still to hand it in, and therefore she gets a place on the excursion. So Kate's statement is also incorrect. She doesn't believe in herself enough, right? There is a chance that she hands it in on Friday and she's the first 50 to hand it in. So therefore, neither Kate nor Megan have handed in the neither Kate nor Megan have got a correct reasoning. All right, let's keep on going to question 19. Now with question 19, again, we have one of those visual spatial reasoning questions. And this time we see a drawing which shows an L-shaped box, as you can see. And it's now asking us which one of the following nets below cannot be folded up to form the L-shaped box. So as you guys might know, the net diagrams are basically what happens if you unbox the 3D shape into its different faces. All right, and technically, when you fold up a net diagram, it should then form this 3D L-shaped box. And it's now asking us which of these four options cannot be folded up to make that L-shaped box. So the trick to doing this question is actually all about pattern recognition again. Okay, so what you should know is that the two L-shaped faces are very distinctive, right? You got to have one on the left-hand side, so one over here. And there's also going to be one on the other side that we can't see, right? So we expect there to be two L-shaped faces. And another thing to remember is that these L-shaped faces has to be joined together by a rectangle. Because if I were to draw what it would look like in dotted lines behind this diagram, is there should be a rectangle on the bottom or on the back here that joins together the two L shapes, right? So what I mean is there should be an L shape like this that's then joined by a rectangle to another L shape. And then when you fold these two L shapes upwards, it's gonna start forming the diagram that we see there. All right, so now we should look for this sort of pattern in the actual answer options, because that's what's required to form the actual L-shaped box. And you can see this pattern in all the options. A, you can see it over here, right? And I might just draw the outline for you. You can see that there are two L shapes joined together by a rectangle in the middle. Same here. And same in option B. But what happens when we look through option B? We notice that there are two L shapes that are not joined together by any rectangle. And therefore, it would be quite impossible to make the L-shaped box that we see above. And that, my friends, is the quickest way of doing this question, is by recognizing that pattern. Now let's have a look at question 20. So question 20 is one of those problem-solving questions. So let's have a read through the information and then try and represent it in a diagram. Remember, the key way to approach this type of question is by doing a diagram. So for the last 5 years, Colby Street eating pie, not street eating. For the last 5 years, the Colby Street pie eating contest has been won by a different person every year. Now that's important, so let's just keep a note of that. A different winner every year. 2 years ago, the winner was Mr. Green and Miss Black was the runner-up. Last year, 4 contestants entered: Miss Green, Mr. Green, Mrs. Black, Miss Orange, and Miss White. And then they give us a bit of information about the contest. The question is asking, who was last year's runner-up? Okay, so the first thing I'm going to do here is draw a little diagram. And we're going to have the first position here and the last position here. And we know there's 4 contestants. So this is going to be first. That's going to be second. That's going to be third. And this is going to be fourth. Okay. All right, now let's start filling in the information. We know that over here, Ms. White had no appetite and finished last. That's pretty easy. Let's put Miss White here in fourth. And then we know that Ms. Black started well, but didn't do as well as last year. So last year, what did Miss Black position in? We know that Ms. Black was the runner-up. So if she didn't do as well as last year, she can't have been the runner-up or second. She must have been, in this case, third, since Ms. White is already fourth, right? So we know that Miss Black must have come third, since she didn't do as well as second from last year. So the question is now, who was last year's runner-up? So we're only left with two options now, right? We know that the runner-up can't be Ms. White and it can't be Miss Black because they are third and fourth. It has to be between Mr. Green and Miss Orange. Now, we already know that Mr. Green was the winner 2 years ago. And you can't, each year, there's a different person who wins it. So Mr. Green can't have won it again. He couldn't have won it 2 years in a row. So Mr. Green can't be first. He must therefore be second, and second is the same as runner-up, guys. So therefore, our answer is going to be A. And therefore, just for completeness sake, we know that Miss Orange was first in last year's contest. All right, let's keep going. We'll go now on to question 21. Okay, so for question 21, let's zoom in a little bit more. It says, to qualify for the Kings County Volleyball Trophy Finals, teams must meet at least one of three conditions. So at least one of these three conditions. It's either coming first or second in their qualifying group, scoring 15 points or more in the qualifying stages, or winning the third player award in the qualifying stages. Lucy is looking at the qualifying results and planning the final stage of the tournament. So Lucy says there were 6 groups. So 12 teams came first or second. That sounds correct so far because, there's going to be 2 people who come first or second in each group. So 6 lots of 2 is 12. And then she goes on to say that 14 teams scored at least 15 match points. Okay, so we know that 14 of them scored 15 or more match points. 12 came first or second. And of course, 1 team won the Fair Play Award. So I should plan for 27 teams in the finals. Which one of the following sentences shows the mistake Lucy has made? All right, so for question 21, again, it's looking at identifying reasoning errors. So you can see that what Lucy has done is she's actually just said, okay, there's 12 teams that come first or second, so I write 12 there. And then there's 14 that won 15 match points or more. And then there's 1 team that won the Fair Play Award. And she's just gone ahead and added all of these up to get to the number of 27. The issue with that approach is, what if there was an overlap? What if a particular team met more than one of these conditions? So for example, what if there was a team that came first and they also scored more than 15 points, right? And of course, they've contributed to this number and they've also contributed to that number. So if you add it all up straight away, you've double counted that team. And technically, only 26 teams need to be in the finals. So Lucy has not accounted for that. She's just assumed that none of the teams have, that all of the teams have only just met one condition. She's assumed that none of the teams have met more than one of those conditions. So let's have a look at the answer option that actually says that. And I'll just direct you guys to answer option B. So it says some teams may have met more than one of the conditions. There will So there will be fewer than 27 teams. And that's exactly what I've tried to show you in that example above here, right? So there's definitely an assumption that Lucy has made where she's just assumed that each one of these teams has only met one condition, where there definitely could have been a chance that there was a team that met more than one of the conditions. And so that is probably the best way to explain that question. We'll keep on going. Let's have a look at question 22. So question 22 says, I have a 6-digit code for my bike lock, and it gives us a bunch of conditions. Again, remember, these types of questions, you got to draw a diagram. Just have to. It's probably, it just visualizes all the information in one particular place. Okay, so first I'm going to start off by drawing a 6-digit code. So I'm just going to draw 6 lines that represent the codes, the numbers. And let's start reading through our conditions. So the 2-digit number formed by the middle 2 digits was the result of multiplying the first digit by the second digit. So I just quickly try to represent that, guys. So we know that the first digit, which is, I might just label it for you guys. First, second, these are the middle 2 digits. And these are the end 2 digits. Middle 2 digits and end 2 digits. Okay, it says that the 2-digit number formed by the middle 2, so these 2 over here, was the result of multiplying the first one by the second digit. So these 2 multiplied would actually equal to the middle 2 digits, okay? And then we know that the 2-digit number formed by the last 2 digits of the code, so over here, it's double the number formed by the middle 2 digits. So whatever this number is here in the middle, if we multiply by 2, it should equal the last 2 digits, okay? So just keep that in the back of our mind. And then it says the first digit was 7, so that's nice and easy. We put 7 in there. And then all 6 digits were different. Okay, so now you've got it all represented in one diagram. It's actually just a matter of trial and error from now on, okay? So you know the second digit, it can't be a 1, because 7 times 1 just forms 7, and that's not a 2-digit number, right? So logically, you go for 2 first, guys, okay? So if the second digit was 2, 7 multiplied 2 gives you 14, okay? So that means these 2 numbers in the middle, 14, 1, 4, and we know that the last 2 digits is just 14 multiplied by 2, which is 28, so that's 2 and 8. Now, does that work? No, it doesn't actually, because we know that all 6 digits need to be different, and you got 2 coming up twice here. All right, so we know that we did trial and error, and 2 wasn't the right one to guess for the second digit. So we got to redo everything. So now let's try something like 3. Logically, that's where I'll go for next. So 7 times by 3, 21, looking good so far. But 21 times by 2 gives you 42. And again, you notice that 2 comes up twice, and we can't have that because they all need to be different. So back to the drawing board we go, and now instead of 3, we should try the next number, which is 4. So 7 times by 4, that's 28. Okay, so far so good. 28 times by 2, that's 56. And voila, all of the digits are different, and therefore this has to be one of our answers. And it says the last digit is 6. So therefore our answer should be C. So trick to this question, drawing a diagram and a little bit of trial and error. Let's keep going. So now let's go to question 23. Now with question 23, let's have a read of it. Again, it's one of those assessing the impact of additional evidence questions, and we're looking for an answer option that strengthens it. So just remember that. So let's read through the question now. It says that a famous archaeologist has said that although it is vital to encourage public interest in archaeology, large numbers of people should not be allowed to visit historical sites of interest because they cause lasting damage to the site over the years. Okay, and which of the following statements is true would strengthen the archaeologist's argument? So first thing is, let's represent the argument in a little bit of an equation or flowchart. So we know this archaeologist has argued that it is vital to encourage public interest, right? But we can't allow too many people to visit them because they will cause damage, okay? So he says it is vital to encourage interest in archaeology, but we can't allow too many crowds, right? But we cannot allow large crowds, and that's because they cause damage. People cause damage. Let's just say crowds cause damage, okay? All right, so I've summarized that into this little flowchart. Okay. All right, so we basically get the idea that this archaeologist is arguing that, yes, we need to encourage archaeologists' interest, but we can't have too much interest, basically. We can't have large crowds because they will end up causing damage to the historical sites, okay? So if we want to find something that strengthens the archaeologist's argument, it's basically something that says, yes, we need to have some way of, increasing the interest in archaeology, but we also understand that we can't have too many people there as well, okay? So let's look at option A. It says, it is possible to create accurate replicas of historical sites to satisfy the interest of the general public. So option A, actually, it acknowledges already that we need to encourage interest because it mentions how we need to satisfy the interest of the public. So it acknowledges this part of the this part of the person's arguments, right? So it acknowledges that. And it also kind of provides a solution to the large crowd. It says, instead of having everyone crowding around the actual historical site, we can create replicas. So it provides a solution here. So I would say A definitely is an option we should consider because it has strengthened the archaeologist's argument by saying, yes, we need to satisfy the interest in archaeology, but instead of having large crowds, we can just create some replicas in museums. So, we need to create some replicas of the historical sites so we can distribute people across the sites instead of having a large crowd at one. Okay. So it does strengthen the archaeologist's arguments. Now let's have a look at some of the other options, okay? So option B says, people's fascination for experiencing the ancient world is an important part of tourism. Okay. So option B is saying that, yeah, we need people to be interested and fascinated about archaeology because it's a part of tourism. So it's kind of acknowledging this first part here, but it doesn't really talk about not allowing large crowds. So it doesn't really strengthen the archaeologist's argument. It doesn't provide any sort of solution there. It's kind of just saying, yes, people are interested in archaeology and that's important for tourism. So it kind of is irrelevant to our argument here. It doesn't really seem to be much to do with what the archaeologist is trying to argue here. So I would say it's a bit irrelevant. And now option C says, many historical sites around the world have already banned visitors in order to prevent damage. And just want to draw your attention to the word banned, guys. So the archaeologist has said we can't have large crowds. It didn't say we have to ban visitors. So although this option might seem like a really good answer because it's saying, yeah, we can't have large. It's archaeologists said we can't have large crowds, and option C is saying no. Wait a second, not even large crowd. Let's just ban visitors altogether. So it's like super strengthening the archaeologist argument, but actually it's not. It's not actually strengthening it because it's kind of going against it. The archaeologist just wants to limit the number of people visiting the historical sites. Nowhere does he mention that he wants to ban the visitors. So this one actually goes against it, and we have to actually roll it out. Okay, so it's actually weakening the archaeologist's argument. It's kind of saying it's going a bit too extreme. Okay, and then you have option D, which says there is a growing interest in ancient history, especially amongst young people. So again, D is kind of acknowledging that there is an interest here, but it really doesn't talk anything or provide any sort of solution about the large crowds at the archaeology site. So again, it's not the best option. So you can see none of these options were really that strong, but A was something that acknowledged both sides of the both parts of the archaeologist's arguments, right? It's acknowledged the interest and it's also provided a solution to the large crowd issue. Okay, so therefore option A most strengthens the archaeologist's argument. All right, let's keep going. So question 24. Question 24 is again one of those detecting reasoning error questions. So let's again look at the scenario and try and summarize it into a diagram. It says there are 3 ways to cross the Kora River. Archer Bridge is open to cars and pedestrians. It is only open on Mondays, Wednesdays, and Saturdays. It is one of the highest bridges in Australia. The Jordan Bridge is open to cars but not pedestrians. It is only open on Tuesdays, Thursdays, and Fridays. The Kora River is for pedestrians only. It is open on Sundays. It is also open on other days, but only if the bridge that would normally be open is damaged. A lot of information, right, guys? So we've got to make sure we just summarize it into a nice little kind of diagram. So we know there's 3 ways to cross the Kora River, right? So let's write here, cross river. We got 3 options. We got Archer Bridge, but you're only going to go over the Archer Bridge if you're in a car or if you're a pedestrian. So I'm just write people for pedestrian, and you're only going to be able to cross Archer Bridge on Monday, Wednesday, and Saturday. Second option is the Jordan Bridge. Right, and the Jordan Bridge is only open to cars, and it's only open on Tuesdays, Thursdays, and Fridays. And then lastly, you have the ferry, the Kora ferry. And again, this is for people only, and it's only open on Sundays plus other days when the bridge is damaged. So I'm just going to write when bridge is damaged. Okay, so now that we have all the information summarized really nicely, let's have a look at our questions. So, our statements. So start off with Amanda. Amanda says, if the ferry operates for 3 days in a row, it must mean both bridges are damaged. Okay, so to figure out if Amanda's correct or not, let me draw your attention to a particular example. Let's say the ferry was open for 3 days in a row, right? So let's say it was open on Saturday, Sunday, and Monday, right? We already know it's normally open on Sunday since, the ferry is open on Sunday normally already. Okay, so that's, I'm going to write here normal, right? Because normally it's already open. Now, if it was open on Saturday, which bridge would have been broken? It would have been the Archer Bridge, right? Because the Archer Bridge is normally open on Saturday. And so if the ferry is running, therefore you can logically say that Archer Bridge was broken. So I'm going to write Archer broken, right? And then what about Monday? So again, on Monday, it's the bridge that's normally open is Archer, right? So if the ferry is now operating on Monday when the Archer Bridge is normally supposed to be open, that means the Archer Bridge must have been broken as well on Monday. Okay. So in this particular example, you can see that the ferry is operating for 3 days in a row and only the Archer Bridge was broken. And so therefore, Amanda's statement is incorrect. Okay. We found a scenario that actually contradicts her statement. Now let's look at Declan's statement. Declan says, I don't have a car and I'm terrified of heights. So he doesn't have a car means he can only he can't go across the Jordan Bridge. Okay, so that's a no-no. So I just draw a cross here. He's really scared of heights. Remember, the Archer Bridge is one of the highest bridges in Australia, so he can't go across there. So, and he says, that means he must go via the ferry, right? And he goes on to say that unless I get someone to drive me, I'll only ever be able to cross on a Sunday. So we already know that Declan, he can't go across the Archer because the bridge is very high and he's scared of heights. He can't go across the Jordan because he doesn't have a car. And yeah. And so that means he must go via the ferry. Yeah. And if he goes via the ferry, he believes that he can only cross on Sundays. But is that true, guys? We know that the ferry might also operate when the bridge is damaged. So it's not always going to be on a Sunday that he can cross. There might be another day when the bridge is broken that he then can cross via the ferry. So again, Declan's wrong in assuming that he can only go across the river on a Sunday. He could totally cross via the ferry on one of the days that the bridge is damaged, for example, on a Monday. So therefore, again, Declan's incorrect. And so in this case, neither Amanda nor Declan have made a correct statement. So the answer option is D. All right, let's have a look at question 25 now. Question 25, it says there's a group of 60 students asked to name their favorite game. The games were then identified as one of 4 types: card games, board games, computer games, or other. And it's given us, again, some conditions to work with. Okay, so it says that 15 of the students named a card game. So what we'll do is you can see that the answer options is asking us to which of the following pie charts could correctly represent the information above. So quickly, we should turn this into a fraction. All right. So if 15 students named a card game out of 60, then the fraction we should write is 15 over 60. And we can actually simplify that to 1/4 by dividing the top and bottom by 15. Okay. Right, and we're going to get to 1/4. And 1/4 on a pie chart should just be a quadrant, right? It should look like something like this. So immediately after this piece of information, I'm just going to go through our answer options and eliminate anything that doesn't have a quadrant in it. Okay, and what's that? That's actually just option B. Option B doesn't have a quadrant. Every other option still does. Okay, so we're going to keep reading. We've acknowledged this piece of information. Then it says twice as many students chose a computer game as chose over a board game. So twice the students chose a computer game as compared to a board game. So now between options A, C, and D, we need to look for a pie chart where one of the slices is twice as big as the other one. Okay, so that's what we need to do. That's what we have learned from this one, is one slice is twice another slice. Can you find the answer option with that one? Well, if you look at answer option A, guys, you've got this slice here, but this slice over here is way more than twice that slice, so it can't really be option A. Then we have a look at option C. Again, this is the small slice and this is the very big one. and you can see that, no, this one is definitely way more than twice as big as that one. So again, can't be C. And that kind of leaves us with option D, and let's have a look. Option D, you notice that there's this smaller slice here, right? And it is actually exactly, this one here is exactly twice that size. If I draw a line in the middle here, you can see that this one is twice as large as that one. So you have satisfied now this condition with option D, and that therefore has to be our answer. Okay, so now let's go through question 26, which says, if we don't sell 3/4 of the tickets, then the school play will be cancelled. If the play goes ahead and we make it a success, then we might just be able to convince the principal to let us put on another play next summer. It won't be a success though if people don't work hard and learn their lines. If the play is not a success, then it will be the last play we are allowed to do. Which one of the following outcomes is not possible? So when we approach these types of questions, again, we'll try and draw it into a little bit of a flow chart just so we can picture the logic a bit easier. So I'll start us off by focusing on the first part here. It says, if we don't sell 3/4, then the school play will be cancelled, right? So if you don't sell 3/4 of the tickets, then the play is cancelled. Okay, and we know that's true because it's actually said in that first line. So this is a true statement. Now, what I call the opposite logic might not necessarily hold as well. So let's give you a hypothetical situation. Now let's say they do sell 3/4 of the tickets. Do you think that means play continues? Now, it might be very easy and common logic to think that yes, because you didn't sell, because it says, if you don't sell 3/4, then we'll be canceling the play. It's a very easy to assume then that if you do sell 3/4, that the play will continue. But no, that actually isn't true. It's actually a false thing to assume because it hasn't been explicitly said in the actual scenario that if you did manage to sell more than 3/4 of the tickets, that the play continues. It doesn't say that. So we can't actually assume that to be true. And so this is what I call that a statement like the opposite logic is not always true. Opposite logic is let's call it an assumption, okay? You cannot just assume that the opposite of what's being told will then be another true statement. And so if you now look at option A, guys, which says the play did not go ahead even though they sold all the tickets. So they sold all the tickets. Most of us will now think the play goes ahead, right? But no, remember, opposite logic is an assumption. So even though they sold all the tickets, there's still a chance that the play is cancelled, right? Because the question has not explicitly said, yes, if we sell more than 3/4 of the tickets, then the school play will continue. It does not say that, right? So we can't actually assume that if they sell all the tickets, the play continues. Therefore, A is a possible outcome, right? And if it is a possible outcome, it can't be our answer because we're actually looking for an outcome that's not possible. Okay. Now you can actually apply the same opposite logic to B and C as well. Okay. And I won't go through those in detail, but I can tell you that the same logic can apply to those scenarios in B and C, and those outcomes would all be possible as well. Okay. And now let's just focus on our attention on option D. Option D says the principal let them put on another play even though they didn't learn all their lines. Okay. So let's examine what's been told. We know that if the play goes ahead, it's a bit too thick. If the play goes ahead and we make it a success, then we might just be able to convince the principal to let us put on another play next summer, okay? So we know the only way that they might get another play next summer is if they make it a success, okay? All right, now let's keep on reading. We know it won't be a success if people don't work hard and learn their lines. Let me just put that into a flowchart. If they don't, so cross meaning don't, they don't work hard or learn their lines, then we know that it won't be a success, so cross for success. And we know that if it's not a success, then there's no way the principal will allow another play. Because we can read that if they do make it a success, then they might have a chance of convincing the principal to put on another play. So if the play is not a success, then the principal won't even think about putting on another play, right? So option D is an outcome that's not possible, okay? Because you can clearly see in this flowchart, if you don't learn all your lines, it won't become a success, and therefore you won't have another chance, another play. And option D says the principal let them put on another play even though they didn't learn all their lines. It's not possible for that to happen. Therefore, option D is our best answer. Let's go to question 27 now. In question 27, it says that the Port Sunday canoe race is held once per year. There are 3 ways to qualify. Any team that comes first or second in the regional heat qualifies automatically. Okay, so let's just write condition 1. So to qualify, there are 3 ways. The first way is if you come first or second in the heat. The other way is if you have the last year's winning team with the same members. Okay, so last year's winning team with same members. And then thirdly, you have a wild card, right? You could qualify as a wild card, which is a team that's chosen randomly from all the teams that failed to qualify. Okay, so we know that Glenn and Hayden are on the same team this year, and they're trying to qualify. Let's have a look at their statements. Glenn says, we came third in our regional heat, so they can't qualify through this way. We won the race last year, so they are last year's winning team, but one of our members has left. So our only chance of qualifying is to get her to come back. No, that's not true, because you have this third option. You could also qualify as a wild card. So, you have another option. It's not just getting your old teammate to come back. So therefore, Glenn's statement is incorrect because we know that they can also qualify as a wild card. Then Hayden says, if we can get her to come back, it won't matter that we didn't do well in the regional heat. Because if their old teammate does come back, they meet this criteria, right? They're last year's winning team with the same members. So Hayden's correct statement is correct. They will be able to qualify if they get their old team member to come back, and it won't matter that they didn't do well in the heat. So therefore, it's Hayden only has the correct reasoning, and therefore the answer is B. Let's now move on to question 28. It says, at a zoo, there are snakes, horses, and eagles. Snakes have no legs, horses have 4 legs, and eagles have 2 legs. There are 9 of these animals altogether with 10 legs in total. What's the highest number of snakes that can be at the zoo? Okay, so we just need to do a little bit of logical reasoning here. If you want the highest amount of snakes, then you want actually as many horses as you can fit, because the horses are then going to contribute, each horse is going to contribute 4 legs and really help get you up to this the count of 10 legs in total. Yes. So using our logic, we know that to get the highest amount of snakes, to get the most number of snakes, we will actually want as many horses as we can get. We want as many horses as possible. Let me give you an example. So let's say there's 3 horses. If there's 3 horses, then each of them have 4 legs. So that means there's 12 legs in total already. We've already overshot the total legs. So we know that there can't be 3 horses. That means the most amount of horses that we can have is actually 2, right? And 2 horses will contribute 8 legs. Okay, and so that means there's 2 more legs that we need to get a total of 10. And what has 2 legs is an eagle, right? So that means we just need 1 eagle to contribute the last 2 legs, and we get our total of 10, right? And the remaining animals can just be snakes, and snakes obviously have 0 legs. So we've already met our leg requirement, 10, right, in total. And how many animals do we have so far? We have 2 horses and 1 eagle. So that means we need 6 more animals to get a total of 9. So that means snakes there have to be 6 of them, right? And therefore our answer should be C. And just for completeness, snakes, you know that snakes have 0 legs, so they're going to contribute 0 legs, and the total is still going to be 10 there. So that's good. All right, therefore the maximum amount of snakes that can get the zoo is 6. And it's all dependent on having as many horses there as possible. Excellent. Let's now move on to question 29. 29 says, there are 3 men, Arthur, Bobby, and Darren are suspects in a crime investigation. Only 1 man is guilty. Okay, only 1 man is guilty. When they are questioned, to give the following statements. So Darren says, Bobby is guilty. Bobby says, I'm not guilty. Arthur says, I'm not guilty. However, only 1 is telling the truth. The other 2 are lying. Which one of the following statements must be true? Okay, so the best way to approach this type of question is actually by doing scenarios, okay? And the easiest 2 scenarios to consider is whether Darren is telling the truth or he's not, right? So that's pretty much the easiest way to split the scenarios. Either Darren's telling the truth or Darren is lying, right? Because we know one of them have to be telling the truth. So let's consider both scenarios, okay? Scenario 1, Darren tells truth. Now, if Darren is telling truth, then what does he say? He says that Bobby is guilty, right? And he's telling the truth, right? So that means Bobby is guilty. Bobby is guilty. So Bobby's our guilty man now, okay? So I might just write here, guilty man, Bobby. Now, if Darren is telling the truth and only one of them is telling the truth, that means the other 2 must be lying, right? So that means Bobby and Arthur both have to be lying. And what we have to do is make sure all this information comes together and makes sense. So now, if Bobby is lying and he says, I'm not guilty, that makes sense, right? Because Bobby is the guilty man and he lies by saying, I'm not guilty. So that is true. He's lying. Yep. And then now let's look at option Arthur. Arthur says, I'm not guilty. And then, but remember, Arthur's lying. So if Arthur is lying about saying, I'm not guilty, he's actually saying, I am guilty. And that's no good, right? Because we already know the guilty man is Bobby. So Arthur can't be the guilty man. So therefore, scenario 1 doesn't work. it's not the scenario that works for us. Okay, so we have to now consider scenario 2. Okay, there's a the facts don't add up in scenario 1. Okay, so therefore let's now move on to scenario 2, which is where Darren lies. Okay, now let's just run through the scenario. So if Darren is lying, and he says Bobby is guilty, that means, since he's lying, that means Bobby is not actually guilty, right? Bobby not guilty. Okay, now let's look at Bobby's statement. Bobby says, I am not guilty. We already know that if Darren is lying and he's saying Bobby's not guilty, then Bobby, by Bobby saying I'm not guilty, he's actually telling the truth, isn't he? Right? So Bobby's actually telling the truth. He's saying I'm not guilty. So far, everyone's statements is making sense with each other, right? And if Bobby is telling the truth, that means the other two are lying, right? So that means Arthur has to also be lying. And since Arthur says I am not guilty and we know he's lying, that means Arthur is guilty, right? Arthur is guilty. So we know our guilty man is now Arthur. And now, does everything in scenario 2 add up? Right? It does. Everyone's statement is making sense, right? We know that one of the 3 men is telling the truth, which is Bobby. He is saying that I'm not guilty, and then the other 2 are lying, and our guilty man is actually Arthur. Okay, so we know that scenario 2 actually works out. Okay, all the everyone's statement is making sense with everyone else's, and we've met all the conditions, which is one of the men is telling the truth and the 2 other people are lying. Okay, so which of the following must be true then? Let's have a look. Darren is guilty. No, that's not true. We know Arthur is guilty, so we can cross that out. Option B says Bobby is lying. No, Bobby's telling the truth, right? So Bobby is indeed, that is also a false statement, B. C says Arthur is not guilty. No, remember we concluded Arthur is a guilty man, so it's not going to be C. And therefore, it has to be D, right? Is Darren lying? Yes, Darren is indeed lying. So this is the true statement. Okay, so the way to approach question 9, as you can see, is just by considering the 2 easy scenarios, whether Darren is lying or Darren's telling the truth. Now, you could have applied it to anyone. You could have applied the scenarios to just Bobby's statement. So you can either say Bobby is telling the truth or Bobby is lying. You're going to end up with the same answer in the end. Okay, so you just need to create 2 scenarios for yourself based on any one of those 3 man statements. Okay. Let's now move on to question 30. So question 30 is saying, again, it's one of those identifying assumptions. We have to identify the assumption that Ms. Linda has made. So let's read through the question. It says the Northern Intercity Railway employs inspectors to check that everyone traveling on a train has a valid ticket and catch anyone trying to ride for free. Anyone caught without a ticket has to pay a $500 fine. In the last 5 years, not a single person has been caught without a valid ticket. Okay, and let's have a look at Linda's statement. Linda says, that just shows that tickets inspectors are a waste of time and money. They never catch anyone. The railroad should save the money or employ them to do something more useful. Okay, and which of the following shows the assumption that Linda's made? So again, let's just represent Linda's conclusion into a little bit of a flowchart. So she's basically concluded that ticket inspectors are not useful because they don't catch anyone, right? So based on the fact that, in the last 5 years, no one has been caught. No one has been caught. in past 5 years. And because of that statistic, Linda now makes this conclusion or this argument that ticket inspectors are not useful. Okay, so we need to show a mistake or assumption that Linda has made. Now, let's look at option A first. So in option A, it says, fear of being caught may be the reason that nobody tries to travel without a ticket. So we need to look for an option that kind of breaks Linda's logic here, okay? And if I told you that, you know, no one has been caught in the last 5 years purely because they're scared of traveling without a ticket, since there are ticket inspectors, that actually shows that ticket inspectors are useful, right? Because ticket inspectors, based on option A, they create a fear of being caught, and therefore are useful, right? So therefore they are useful. And we have very much, attacked the logic in Linda's argument. She's saying they're not useful because there's no one being caught. But maybe the reason no one's been caught is because these ticket inspectors, they create a sense of fear of being caught and therefore prevent anyone from actually trying to travel without a ticket. So A very much does show the assumption that Linda's made, and it destroys the logic in her conclusion, right? And so I think answer A is a very strong option, but we have to be, again, careful and exclude all the other options. Okay, so if we have a look at B, it says, just because nobody has been caught in the last 5 years does not mean they will not be in future. Okay, and again, that doesn't really have anything, it doesn't really show any assumption that Linda's made, because Linda is really talking about the usefulness of the ticket inspectors, right? And B is just kind of giving you a hypothetical situation where because no one's been caught now doesn't mean necessarily they won't be caught in the future, right? So B is a bit of an irrelevant statement there. And then option C says the Northern City Railway may not have anything more useful to spend the money on. Again, not very relevant to what Linda's trying to say. Linda's trying to say, we should, basically saying the ticket inspectors are not useful since they haven't caught anyone in the past 5 years. It doesn't really show the assumption that she's made. So again, C is quite irrelevant. And then you have D, just because the inspectors have not caught anyone does not mean that nobody has traveled without a valid ticket. Again, this answer option here is purely telling us that, there is a chance that somebody has slipped through the gates of a ticket inspector. And therefore, it's actually contradicting, Linda's statement. Linda's trying to say that ticket inspectors are not useful. Now, if someone has been slipping through the inspector's grasp, that means probably you need more inspectors, right, to try to catch that person. So again, D doesn't really show the mistake that Linda's made in her conclusion, and therefore A is going to be our strongest option there. Okay, guys, let's keep on going. So let's go to question 31 now. So again, we got one of our visual spatial reasoning questions, and it's telling us there's a 6x6 square puzzle is shown below. It's made up of 4 white pieces and 1 black piece. Which one of the following black pieces will not fit with the 4 white pieces to make another 6x6 white square? Okay, there's actually 2 ways of doing this. In the exam, where time is a bit of a concern, you want to consider the shortcut method first. So you kind of eyeball the 4 different options, and what should stand out to you is option C. It's a very awkward looking shape that wouldn't really, it's difficult to fit these four shapes around it to make an actual square puzzle. So let me just show you what I mean. So you look at it and you see the bottom part of here. So you can, consider drawing one of those shapes here, like so, right? But you can't actually make this into a perfect square with the black shape like it is here. Even with the top shape, if I put in something like this, and then another thing like this, you can see you can't actually ever get it to become, this square shape. Whereas the other ones, you can. So by eyeballing in the exam, you can hopefully quickly deduce that it should be C. That's not very possible. Otherwise, the thorough method is to show you all the other options as well. So that's what I will demonstrate now. So in option A, you're able to make the shapes by drawing it like this. So something like this. There you have all four white shapes around it, creating that perfect square. And over here, you have something like this. Let's just make that a little bit clearer. Right, so you have 1, 2, 3, 4 white shapes around it like that. And then lastly, you have option D, which looks like something like this. So 1, 2, 3, 4. And again, you can see that you can create a perfect square there. So that leaves us with the best answer of C here. Let's now move on to question 32. So in question 32, you've got when Olivia got a car, her cousin Natalie said to her, more people are injured in car crashes between 4 and 7 p.m. than at other times. This means you should be more careful driving then, as you are more likely to get hurt in a crash. Which of these statements, if true, most weakens Natalie's argument? So again, the same approach, we should try and summarize Natalie's argument. And basically she's saying that because there's more injuries from crashes between 4 to 7, you should be more careful during that time period. Okay, so more injuries from crashes between 4 to 7 p.m. And because of that fact, she's now concluded you need to be more careful in that time period. In that time period. Okay, now let's have a look at our answer options. Now, if you look at option A, it says many more people drive between 4 and 7 p.m. than at other times. So option A is actually saying that there's a lot more people driving between 4 to 7 p.m. and therefore, because you have a high amount of people driving, there will be more injuries. So it doesn't actually make, you don't actually need to be more careful during that period. The high amount of injuries from crashes is simply due to the higher volume of traffic. So it actually does weaken Natalie's argument. It makes her point kind of obsolete because it kind of explains why there is more injuries between 4 and 7 p.m. because of the high volume. Okay, so it explains that there are more people driving and therefore more injuries from crashes between 4 to 7. So her advice or her conclusion is kind of made unnecessary or irrelevant because there's more injuries from more people driving. So A is definitely one of the options that we can consider that weakens her argument. So I'll leave a dash there. Now B says Natalie has never driven a car herself. Now that is kind of very irrelevant to what she's saying. She's arguing that you need to be more careful since there's more crashes during 4 to 7 p.m. Has nothing to do with the fact that she's ever driven the car. So B is what I call irrelevant. Option C says people can still have car crashes even when they are driving carefully. And again, this is a good option that weakens Natalie's argument. I'm going to put a dash through there. And that's because she's saying that, Natalie's arguing you need to be more careful because there's more injuries that occur between 4 to 7 p.m. And C is saying, yes, even if you are driving carefully, you can still have a car crash. So it definitely does also attack her argument's logic. And then lastly, D says, Olivia has no choice but to drive at that time because she finishes work at 5 p.m. And again, option D is very irrelevant here. Like telling me the fact that there's no choice but driving at this time does not actually weaken or strengthen Natalie's argument, has nothing to do with it. So in that case, now we are in that situation, the common situation where we have two fairly good answer options, A and C. And now to differentiate between these two options, we really need to look at the one that is clearly attacking attacking Natalie's argument. So if we look at option number A, it actually makes her complete argument null or ineffective, because option A is saying that there's the simple reason why there's more injuries from crashes during this 4 to 7 p.m. time period is because there are more people driving. And it doesn't matter if you are more careful. It's simply because of the higher volume, right? And so that is definitely the strongest option because it makes Natalie's argument completely irrelevant. And therefore, we should go with A in this particular case. And you can see in option C, it doesn't actually, it does address the fact that, you can still have car crashes, but when you are driving carefully, but it's not very, it doesn't make her argument completely irrelevant. It just weakens it slightly. So that's why A is a better option. Okay, let's keep going. So question 33. In question 33, we learned that there are 3 languages of Mekani, Kayana, and Sakludi, and they're quite similar to each other, and they have some words in common. For example, Kanu means house in all 3 languages. Any word that is the same in Mekani and Kayana is also the same in Sakludi. Kayana and Sakludi have a lot of words in common, but never words for animals. Words for animals are always different. Okay, so now let's look at our answer options. It says, if a word is the same in Mekani and Kayana, it can't be an animal. Oh, first of all, before we actually answer all these, we assess Patricia and Yilin's statement, let's just quickly summarize what's being told to us in the scenario in a bit of a flowchart or a diagram. So we know that Mekani and Kayana, that any word, if they're the same in these 2 languages, it's also going to be the same in Sakludi. So I might write something like M for Mekani. If they have the same word, then Sakludi will also have the same word. So it equals Sakludi. Okay. Now we also know that Kayana and Sakludi have a lot of words in common, but never for animals. All right, so now let's have a look at Patricia's statement. Patricia says, if a word is the same in Mekani and Kayana, it can't be an animal. So let's follow what she's saying. We know the word is the same in Mekani and Kayana, and based on the first condition here, we know that if the word is the same in Mekani and Kayana, it also will be the same in Sakludi. But we also know from the second condition that Kayana and Sakludi can't have the same word for animals. So what Patricia is saying is actually true. If that word is the same for Mekani and Kayana, and thereby also Sakludi, it can't be an animal word, according to the second condition. So therefore, Patricia's statement is actually correct. Now let's have a look at Yilin's statement. Yilin says, if a word is the same in Mekani and Sakludi, it can't be an animal. So the issue with Yilin's statement is she's comparing words between Makani and secludity, and you can see none of these conditions actually show a direct correlation between M and S. We have a condition for K and S, and we have a condition for M and K, which then leads to S. But there's nothing actually directly connecting M and S. So we can't actually say if Yiling's statement would be correct because we don't have any information about whether any word in Makani and secludity can be the same for an animal, or if it can't be for an animal, okay? So therefore, we can't actually say Yiling's correct statement is correct. There's not enough information to conclude that. Therefore, her reasoning is not correct, okay? And so therefore, the best answer option is A. Let's now move on to question 34. So in question 34, we have Izzy is making cards to send to all of her friends. She needs to buy blank cards to put her design on. The prices for different sizes of cards are shown in the table below. So Izzy wants to print her design on 67 small cards and 130 medium cards. What's the lowest amount that she can pay for the cards? So again, we're only interested in small medium cards, so we can already ignore all the information down there. All right, we know that she needs 67 small cards. So she can't just buy a pack of 50. She'll need to buy a pack of 100. Now, you have to be careful here, guys. There's two ways you can get to 100. You can buy a pack of 100 for $18, or you can buy 2 packs of 50, right? And that's going to cost you $20. It's cheaper to go for the pack of 100. That's $18. So we know that she needs to spend at least 18 for the small cards. Now for the medium cards, she would like 130. Now, again, there's different ways of getting to 130. You could just outright buy a pack of 250. That's going to cost you $48. Or what you could do is you can buy a pack of 50 for $12 and then buy another pack of 100 for $20, and now you have a pack of 150 as well. And that's going to be the cheaper option, right? So she needs to buy a pack of 50 for 12 and then a pack of 100 for 20. And if you add all of that together, that's going to give you a total amount of $50, and that is the lowest amount that Izzy can pay. All right, now let's go through question 35. So in question 35, it says, in end of year tests, the following results were achieved by students taking maths, physics, and computing. And there's a couple of rules that are given to us. It says that everyone who passed physics also passed at least one of the other 2 subjects. So let's just make a little flowchart of what that is. So if I write a tick, that means they passed it. So if they passed physics, they passed at least one other subject, at least one other subject. And then let's now look at condition 2. It says that no one who passed maths failed computing. So guys, that's just a double negative, right? It says that no one who passed maths failed computing. So there's a negative here and there's also a negative here when you say no one. What that actually means is that if you passed maths, you must have passed computing, right? So we will then write, if you pass maths, you had to have passed computing. And so now that's condition 2. We have written in the flowchart. Now the third condition says that no one passed all 3 subjects and no one failed all 3 subjects. Okay. Now, because of the third condition that no one passed all 3 subjects, if we go back to this first condition here, we know that if they passed physics, they passed at least one other subject. Well, now we can kind of change that. We know that they could only have passed one other subject simply because you can't pass all 3. So we know that they just passed one other subject. So I'll get rid of that and I'll write one other subject. Now, there's only really two possibilities here if you think about it, guys. The other subject that they could have passed would be maths or computing. So let's say they passed maths. Well, we know that if they passed maths, they also did pass computing. Now, so if I write that here, they passed computing, that doesn't actually add up, does it, guys? Because we know that it's not possible for you to actually pass all three subjects. So this branch we actually have to get rid of, okay? We know that it can't be true. So that means if they pass physics, the one other subject that they did pass would have just been computing. So if I was to just reorganize our diagram, it should now just look like, if you pass physics, that means you also passed computing. Okay. So that's the information we have. We know that if you passed physics, you also passed computing. We also know that if you passed maths, you also passed computing. And then lastly, we also know that no one failed all of them and no one passed all of them. So with that in mind, which of the following is not possible? So what we're going to do is going to look through the options and we're going to see if the case is actually possible. If it's possible, then we know that we need to cross out the answer. Okay. So let's look at option A. It says that Luca failed physics and maths. Is that possible, guys? Well, yeah, there is no rule saying Luca can't fail both physics and maths. Yes. So I would say that A is a possible scenario and therefore we need to cross it out. Yes. Now let's look at option B. Option B says Luca passed both physics and maths. Now, is that possible? We know that if Luca passed physics, he also did pass computing, right? So I have to write and computing here. And we know that if he passed maths, he also passed computing. So therefore, you can easily tell that this option B is not possible because if you pass both maths and physics, it means you also pass computing. And we know that no one passed all three subjects. So therefore, we know that option B is not possible and therefore it should be our answer. But just for clarity's sake, let's look through the other options. Option C says Luca passed physics and computing. Yes, that is possible. You can see that that is pretty much the first condition. If you pass physics, you also had to have passed computing. So C is also possible. Therefore, we need to cross it out. Now, option D might sound a little bit confusing, but we have to read it carefully. It says Luca passed either only maths or only computing. So it says either. It means either option could occur. Okay. So is it possible for Luca to pass only computing? Yes, it is. Right. There's no rule saying that you can't just only pass computing. Okay. So that is possible. Okay. And is it possible for Luca to pass only maths? Now, that's actually not possible because we know that if they pass maths, they had to have passed computing. So it's not possible for Luca to pass only maths. So this part of the either diagram or this part of the either question is not possible. Okay, but we can see that option D, one of the potential scenarios is possible, and therefore we have to still exclude D from the answers because there is a possible scenario here, and we are looking for the scenario that's not possible, which is B. Okay, let's now move on to question 36. So in question 36, it says, a famous author has written 3 children's books. The titles are Morning, Noon, and Night. Year 5 did a survey to discover which of the books was most popular in the class. It was found that, again, you're given a bunch of conditions, okay? And we're going to just try and represent that into a diagram. That's probably, as always, the most effective strategy. All the children who read Morning had also read Noon. So what I'll write is, if you've read morning, you also have read noon. And that is always true. And then let's tick that off. Now let's move on to option 2. It says, most of the children who had read morning had also read night. So now we know that most of the children who also read morning had also read night. So I draw another arrow towards night. And now I'm not going to write always, I'm just going to write most, because we know most of the kids who read morning also read night. And then lastly, we know that no child had read night who had not read noon. Again, just be careful. This is a double negative. So it says no child, and it also says had not read noon. So it cancels out. What it actually means is that anyone who's read night has also read noon. So what I will do now is just draw an arrow that says that all the people who've read night have also read noon. So you can see there's this little triangle going on showing the relationship between all the books. Now let's look at our answer, our question stem. It says, we know that Tim has read noon. Which of the following statements is true? Let's go back to our diagram. We know that Tim's read noon, but do you notice how none of the arrows are actually going away from noon? They're all pointing towards noon. So that doesn't mean if Tim has read noon, it doesn't mean that Tim has read morning. It doesn't also mean that Tim has read night, because the arrows are not going away from noon, they're going towards noon. So we can't establish a backwards relationship or a reverse relationship here. And that's a very important tip to be aware of. A forward relationship does not equate to a backward relationship, okay? So also we can call it the forward logic is not the same as reverse logic, okay? So I might just write that here for you guys. It's not equal to the reverse logic. So I give you an example of what I mean. If we know that if I've read morning, I've definitely read noon. Now that does not mean that if I've read noon, that I've always read morning. Okay, so just to really emphasize it, I'll draw this little diagram here. So morning means you've read noon. This backwards relationship is not true. Okay, so big cross through there. If you've read noon, that does not mean you've always read morning. Okay, we can't assume that. Okay, so basically, by telling me that Tim has read noon, you actually, according to our diagram, there's not enough information to tell me whether he's read morning or night. Okay, so the best answer option that we have to choose here is actually option D, which says we do not know whether he has read either morning or night because we don't know what the backward relationship is. Okay, and that is the way to approach this type of question. And you can see it's a lot easier by actually visualizing it in a diagram. Okay, let's now move on to question 37. Okay, so in question 37, we're given a couple of images. We know that the right-hand image is the result of applying a series of changes to the left-hand image. So this is the left-hand image here, and this is our right-hand image here. And then we know that these changes are a difference in the order of the shapes and the application of rotations. So let's just underline that. So we know that the order has changed and they've also rotated 2 of the shapes. Okay, so not all 3 of them. And the question is now asking us, which of the following pairs of images shows the same series of changes applied to the left-hand image to produce the right-hand image? So what I'll do is I'm just going to draw those images one more time, and we're going to analyze them in a bit more detail. So let's focus on the first one. So let's call this 1, let's call that 2, let's call that 3. So the rectangle, if you guys have a look at it, it's in position 1, on the left, right? But when we look at on the right-hand side, it has shifted one space to the right, and it has not been rotated. So this must be the shape that's not been rotated, okay? So this is now going to be move to the right by 1. And that's it. We can conclude that that's what's happened to the rectangle. So the image in the position number 1, it gets moved to the right by 1, and it doesn't undergo rotation. And you can see afterwards that the other two images do undergo rotation, which is what we'll go through now. So now let's focus on the triangle in position number 2. So where does this triangle now go when it's towards the right? So it is in position number 2 here on the left, and then on the right hand side, it's in position number 3. So again, the triangle has moved by 1 to the right. But what else do you notice? At the top, the pointy, the apex of this triangle, or the yes, that side of the triangle has now been rotated to the bottom. So you can see that this triangle has undergone what I call a 180-degree rotation. So let's now write that down. So it's also right, move right by 1. And we also know that this one, the second image, is rotated 180 degrees. Okay, it can be clockwise or anti-clockwise. It doesn't really matter for this question. Then we have the shape number 3, which is the semicircle in position number 3. So now let's see what changes it undergoes when it goes towards the right. Well, first of all, you notice that it goes from position number 3 to actually position number 1. So it actually goes all the way back to position number 1 over here. And what has happened to the orientation of this semicircle? Well, before the curved surface was facing towards the right, now the curved surface is facing towards the left. So we know that this semicircle has also been rotated by 180 degrees. Okay, so I'm going to write move back to the front, and it's also been rotated 180 degrees. So that's what happens to the image on position number 3. So now that you understand what's been changed in the position as well as the rotation of each of these images, we just need to do trial and error and look through the options until we get the answer that actually satisfies all of this. Okay, so you can have a look at options A, B, and C, and you'll notice that one of them won't meet the criteria. Okay, so I'll draw your attention for option A. If we look at the number 2 here, we know that the image in position number 2 needs to move 1 to the right, which it has, but it also needs to be rotated by 180 degrees. And you can see that this 2 has not been rotated. So therefore, option A is incorrect. And then if you look at option B, well, option B, you can already see that the second image has stayed in its same position. It hasn't moved to the right by 1. So therefore, it's also not satisfying the conditions. So answer option B is also incorrect. And then lastly, we have answer option C. Now, in answer option C, we can now focus on this one here again. So the image in the middle should, remember, move to the right by 1, which is what's happened, and then it needs to be rotated by 180 degrees. Now, this actually hasn't been rotated by 180 degrees. It's a little bit hard to visualize, so we'll draw the steps for you guys. So if I rotated this by 90 degrees, what it should look like now is something like this. Okay, if you just follow this this side of the domino, you know that it's on the right-hand side, and after you rotate 90 degrees, it should now be on the bottom, right? And so therefore the dots should follow suit like that, okay? And you can see that that's what it looks like here. So you can see that it's only been rotated by 90 degrees. It hasn't been rotated by 180, which is what's required. So therefore, answer option C is also incorrect. And that leaves us with answer option D. Let's just confirm that it satisfies all the conditions. So you look at in the semicircle in image number 1, you know that it's supposed to move to the right by 1, and it has done so. So it has met that first condition. So I'll give it a tick. Then we look at our rectangle. We know that the rectangle, it's in the middle. It needs to move to the right by 1 and then rotate it by 180 degrees. So it moves to the right by 1. And if you rotate the rectangle by 180 degrees, it still looks the exact same. So that's, again, meeting the requirements. So I'll give that a tick. And then the third requirement is the triangle needs to go to the front, which it does, and it needs to be rotated by 180 degrees, and you can see that it has been. So therefore, our answer has to be D. Let's keep on going to question 38. So for question 38, they tell us that Rob and Paul are citizens of Bolivaristan. In Bolivaristan, whenever the national football team is playing, shopkeepers always decorate the windows with the Bolivaristani national flag. So if I was to summarize this statement, essentially what I would write is something like, if national team playing, that will then lead to shopkeepers decorating their windows with the flag. So let's just say shop decorations. And that's always going to be true, right? Because it says always. So we'll just write that here. Okay, so we know that this relationship is true. If the national team is playing, the shopkeepers always decorate their windows. Again, just remember what I said before, the reverse logic won't always be true. And so therefore, just because someone decorates the shop doesn't necessarily mean the national team is playing. They may have just wanted to decorate the shop, right? So be careful of applying reverse logic. It's never true. So now let's have a look at what Rob and Paul say. Rob says, that's funny. I thought the national team were playing today, but I didn't see any flags in shop windows. I must have got the date wrong. Right. So it basically, Rob is saying he thought the team was playing, but he didn't see any flags. Therefore, the team must not have been playing. He got the date wrong. And that, remember, if the national team plays, there will always be shop decorations. So if there weren't shop decorations, then the national team was not playing. Okay. So if this is not true, then this is not true as well. Okay. So Rob's statement is actually correct. Okay. Since we know that the shopkeepers always put up decorations if the national team is playing. So if the shopkeeper have not, then the national team must not have been playing, and Rob did get the date wrong. Okay, so Rob's statement is true. Now let's have a look at Paul's statement. So Paul's statement says, well, I saw quite a few flags in the shops last Wednesday. Then that must have been when they were playing. Remember what I said about the reverse logic? Even if you see shop decorations, that doesn't mean the national team is playing. It could be just, like I said, they wanted to put up some decorations in their windows, right? The reverse logic does not apply. So please remember that, guys. Reverse logic does not apply. And just to emphasize that, guys, we're going to draw a big cross through the reverse logic there. And so based on that, guys, we know that the best answer here in this case is Rob is correct and Paul is incorrect. All right, so only Rob is correct. That's why 38 is A. Let's now move on to question 39. So for question 39, we're given 4 students had a competition to see who could read the most books. And then again, we're given a bunch of conditions. So the first thing I'm going to do is draw a little diagram. I'm going to write here most books. And I'm going to write here least books. And we know there's 4 students, right? So it's going to be 1, 2, 3, 4 positions. Now, let's have a look at our first condition. It says Olivia did not read the fewest books. So that means Olivia was not 4th, right? Olivia can't be number 4, but she could be in position 1, 2, or 3. We just don't know. We don't have enough information yet. So for now, I'll just leave Olivia out for now until we get more information. Let's have now a look at the second condition. It says only 2 people read fewer books than Carlos. So only 2 people read fewer books. So doesn't that mean that Carlos has to be in the second position because only 2 people, position number 3 and position number 4, read fewer than him. So we know for certain that Carlos was number 2 in the amount of books read. And then lastly, we know that Brian read fewer books than Sharon. Okay. So remember that Olivia did not read the fewer books. So position number 4 cannot be Olivia simply because she did not read the fewest books. And it also can't be Sharon because we know that Brian read fewer books than Sharon, right? So by that, we know by deduction that Brian must have been in the number 4 position. So now that leaves position number 1 and 3 to be filled. The only issue is we don't have enough information to actually figure out whether, number 1 should be Olivia or Sharon. So right now, all we can do is just write Olivia/Sharon for number 1 position and also Olivia/Sharon for the number 2 position. There simply just isn't enough information to differentiate their positions. So now let's have a look at our question. It says, which one of the following must also be true? If we look at option number A, it says Carlos read more books than Brian. And I am inclined to say that, we know for sure Carlos is number 2 and Brian is number 4. So therefore, Carlos did read more books than Brian. It is a true statement. We can circle option number A as our answer. In the exam, if you're confident with your working out, you can definitely go select A now. But again, for completeness sake, let's go through the other options and make sure we've got the answer correct. So then option B says, Brian read more books than Carlos. We already know that's not going to be true since Brian read the least books. He can't have read any more than Carlos. So B is not true. And then let's have a look at option C. Option C says Carlos read more books than Sharon. For that one, you don't have enough information to guarantee it being true, because in one scenario, Sharon is reading more books than Carlos. But if Sharon was in position number 3, then Carlos has read more books than Sharon. Again, there's not enough information to find out right now, so you can't say it must also be true. Therefore, C is also incorrect. And lastly, the same logic applies for D. D says Sharon read more books than Carlos. Because we don't know Sharon's position, could be 1 or 3, we can't tell whether Sharon read more books than Carlos. Again, we cannot guarantee that to be true. Therefore, the best answer is A. And let us now move on to question number 40. The last question in this exam is then another visual spatial reasoning question. And it says, a sculpture is placed in a glass box and displayed in the museum as shown in the diagram below. The sculpture can be viewed from all sides. Which of the following is not a possible view from one of the sides of the glass box? All right, so for this type of question, what you really want to do is kind of imagine yourself standing around the sides of the box and visualizing what the thing could look like. Okay, so let's start off with, let's draw an eye here. Right, if we were viewing it from that angle, you could see basically 3/4 of a circle, right? You're basically going to see that little bit here, and that's going to be answer option C. So we know that answer option C is possible if you view it from there. Now let's say we view it from behind. Okay, now if we view the image from behind, what we're actually going to see is the curved surface, because it actually it's coming towards us, but we're looking at it directly from behind, we're not going to actually be able to visualize that curved surface. So what it would actually look like is just a rectangle. All right. And if you don't believe me, just have a look at a cylinder or any sort of can, like a can of Coke. If you look at the can of Coke from right behind it, it almost looks like a rectangle, doesn't it? Right? And so that's exactly what it would look like in this case. So answer option B is what you would see if you looked from behind the cube. And then lastly, if you look from in front of the cube, what you will see is also the rectangle, but because there is this line here in the middle, you're also going to be able to visualize that line, right? Since that little quadrant of the cylinder has been cut out, right? And so that line is going to transpose to here in the frontwards viewing position, and therefore option D is also possible. And that leaves us with A. And definitely for option A, it's not possible to view such an image from one of the sides of the glass box, and therefore we can confirm that answer A is not a possible view, and therefore the correct answer. And that brings us to the conclusion of all 40 questions of the 2021 Selective Test Thinking Skills paper. I hope you guys found this helpful, and hopefully you've gained some insight into how we should be approaching these different types of thinking skills questions. In particular, with the problem-solving ones, it's really important to draw diagrams to visualize all the information in one actual diagram. And that makes it a lot easier to answer the questions. And then for our critical reasoning questions, it's also very important to draw little flowcharts to represent the arguments and summarize it into one little flowchart. And without further ado, I'll end the video, and we'll see you again next time.